So, गुड मॉर्निंग. आवाज आ रही है पीछे साफ क्लियर? दैट एंड ओके. सो फोकस कैसा है? अभी पता चल जाएगा, है ना? समझ में आ रहा है? थिंग्स आर ओके, क्लियर? Some of you came to me yesterday, so there are parts of that Big Bang part which is not very clear. कौन था? There was a girl from this corner, if I'm rightly recalling. She hasn't come. इतना है ना गड़बड़ हो गया कि लग रहा है आना ही बंद कर दिया. ये आए हुए हैं, ये बता नहीं रहे, ये आज क्लियर हो गया. अच्छा, so the question is not only to her, the question is in general to all of you. Are things getting clear? Come again. यार ये नहीं पूछना है, इतना बड़ा होकर अभी से जॉब नहीं लगा है आपका. मैं आई कम इन सर, ठीक है? मतलब इतना बड़ा होकर के क्लास के बीच में सर मैं आई कम इन, मैं आई गो टू. थोड़ा बड़ा हो यार. होता ना, वो छोटे छोटे बच्चे होते हैं, है ना, उनको जब कुछ नहीं सूझता है क्लास में, right, there is no way they want to be in the class, so they would say मैम भी बेचारी क्या करेगी, क्या तो वैसा नहीं करना है क्लास. जब आना है आइए, जब जाना है जाइए. यू आर ग्रोन अप पीपल यार, यू शुड नो. ओके, सो यस, you have two questions. अगर मैं नहीं पूछता तो आप बताते नहीं आज, तब भी बता देता. गुड, ठीक है. अभी रुक जाओ, आते हैं आपका दो क्वेश्चन थे. I'll come to your questions. लिख के लाया है. ये बुक कौन सा है, किसका है? अच्छा, ऐसा कवर लगा के दे रहे हैं आजकल. वेरी गुड मैम. कवर तक कलर चढ़ गया ना, बहुत है. मेरा बस चलता तो इतना भी पैसा नहीं लगाते इसमें. हाँ, पीडीएफ में कलर ठीक रहता है, ठीक है, इसीलिए पीडीएफ भी दिया है. जितना कलरफुल लाइव देखना है स्क्रीन पे देखिए, रियल लाइफ ब्लैक एंड व्हाइट ही ठीक है. ओके, कॉस्ट ऑफ आप ही से पैसा लेंगे, मेरा कुछ नहीं जा रहा है, ठीक है? जितना कलरफुल चाहिए, जो जो फैसिलिटी चाहिए, 5 स्टार है ना, नीचे वो भी लगाते हैं, सब पैसा आप ही को देना है, सोच लो. सो यस, सो वंस अगेन I'll ask, are things getting clear? Because the doubts of few of you do give me the impression that maybe there are more people who are not speaking, maybe, but there are areas which might not be getting clear, probably because they might be science oriented. That's exactly the reason why I was, why I have gradually reduced the universe part in my initial classes, because I generally find that people have not read the basic science for a long time, so those words become difficult at times for many of us. ठीक है? तो and if that, see, so the whole, there was a purpose why we did that Big Bang to Earth thing. The purpose was to make you understand where did the things on the Earth come from, or where were they made, right? You might ask me, sir, was the Earth all of a sudden made out of nothing? Okay, or was the Earth always there, or where did the elements came, where did it? So in the first 1.5 class that we did, I was just trying to make you understand where did all that element and everything that you find on the Earth, where did it come from, right? So it did not happen out of nothing. There was a very simple natural process because of which it happened. Now in that natural process there would be some science terms which I used. To the extent I could make them easily understandable, I tried. If you did not get that part, it is still okay. I tried my level best that I could at in those moments. If some of you did not get it, that's okay. Why it is okay? Because over the period, as you will read your basic science and then maybe you can attempt it in your second go, that part you will understand. It's not very complicated. And that part is at times also covered in your science class. That's why also I did not put too much of effort in terms of making it, explaining those basic science words here and there. The purpose was to make you understand where did the things come from, and hopefully most of you did get an idea that most of the things that is there on the earth were formed in the stars and supernova, right? And how time and space created the universe along with matter and energy. So this simple thing I believe is clear to most of us, that most of the things that we see around come from these four. Most of the things that we see around are these four things only: space, time, matter and energy, and the earth was formed. And once the earth was formed, I think yesterday we were on the earth and we had already made and destroyed the first atmosphere, and we were making the second atmosphere. I think the second atmosphere also, along with its composition, we had already written, है ना? यहाँ तक हम पहुँच चुके थे. So now tell me this part, this earth part, is it clear to most of you? This earth part of the story, starting from 4.6 to 4.44 to the first atmosphere initially, and then the second atmosphere and the volcanic activity and all this. Is this much clear? इसमें तो कोई complication नहीं है ना, because this is not too much science oriented. This is more of your day-to-day observations. इतना clear है? पक्का? ठीक है? और जिसको भी, whoever, I pointed to that girl because she at least came and asked me those questions. I'm assuming maybe a few of you might not be coming to me and asking those questions. So you can always come, you can always ask. Did you people get some of those, ma'am? Are those PDFs loaded? They are. So did you get to see the PDFs loaded on your platforms? In that PDF, each of the PDF, there is my phone number and my email ID. Both of them are there. You can always not call me. Okay. First, words, mail me. You have the mail ID, send me a mail, right? And WhatsApp भी मत करना, ठीक है? मैं respond नहीं करता हूँ generally. So ऐसा मत सोचना कि सर ने देख लिया respond नहीं कर रहा. मैंने अपना status भी hide नहीं किया है, ठीक है? Privacy settings set नहीं किया है कि आपको पता ही ना लगे कि देखा कि नहीं देखा, right? I don't believe in all that, and I will not respond to your WhatsApp messages whatsoever. कितना भी urgent होगा, ठीक है? Except for 2 days before the exam, तभी करूँगा बस. Because then it is very crucial. तब भी नहीं किया तो आप बोलोगे सर फिर फायदा ही क्या था आपके होने का, है ना? So how do you communicate? Send me SMS saying, sir, I have some doubts. RB this batch student, I want to talk. Right? Please allocate time. I will. Whenever I'll be free, I'll allocate you time, and I would expect you to call back. तो फिर हम बात करके सीधा सीधा, वो लिखने में जितना टाइम लगता है उतने में तो मेरा डाउट क्लियर हो जाता है. ठीक है? Is this okay? Right? So possible, है ना? So आप लोग एफर्ट डाल सकते हैं, I hope. And whoever wants to talk and whoever wants to write, mail, because then I am typing on the computer, it's easier for me. ठीक है? तो that's how we go. Okay? पक्का? ठीक है? मतलब सही चल रहा है ना? ऐसा तो नहीं है, मतलब ज्योग्राफी वैसा ही तो नहीं है ना जैसा पहले था. कुछ इम्प्रूवमेंट हुआ है, कुछ कॉन्फिडेंस आ रहा है, पक्का. कुछों का तो फोकस बहुत ही एक्सट्रीमली हाई हो गया है. तो ठीक है, गुड. चलो आगे बढ़ते हैं. शुड वी? डाउट बोलो. somebody else has a doubt apart from him? None?
For the existence of anything in this universe, or for happening any reaction, we need a medium in which the thing exists or reaction takes place. So since universe is the only biggest entity in which everything exists, then in which medium
Did the universe happen?
singularity takes place?
Which medium singularity took place? Which medium singularity took place? Simple question.
Emergence of the universe.
Obviously, singularity उसके बाद तो है ना, मतलब medium before the universe. One.
And for second, for the expanding any material, we need a medium, like for a balloon is expansion in the atmosphere. So
तुम्हारा बैकग्राउंड क्या है पहले बताओ.
after that,
क्या मतलब क्या किया है कोर्स? इंजीनियर तो नहीं है ना? पक्का? ठीक है. हाँ बोलो, ठीक है, मतलब उसके आसपास पहुंच चुके हो तुम। वो कीड़ा जो है ना, जो उस दिन कोई बोला था यहाँ से, सर कीड़ा होता है। हाँ बोलो।
The like balloon is expanding atmosphere surrounding present. So, since the universe is the only thing in which
मैंने सुनना बंद कर दिया, तुमको पता है?
yes, sir.
यस सर, फिर भी पढ़े जा रहा है। देखो, सिंपल क्वेश्चन, सिंपल क्वेश्चन,
Universe is expanding in
सुन दो भाई। यार मेरा भी बात सुनो, मेरा क्लास है, थोड़ा सुनो। मुझे पता है इंपॉर्टेंट क्वेश्चन है तुम्हारे लिए, बट सुनो, क्वेश्चन इंपॉर्टेंट है, अच्छा है, इररेलेवेंट है। अब इररेलेवेंट है तो क्यों आंसर करें? खत्म, ठीक है। इमोशनल नहीं होना है इस प्रिपरेशन में, इमोशनल नहीं होना है, याद रखना। क्योंकि मेरा क्वेश्चन तो पक्का ही राइट है। मैंने ये नहीं बोला क्वेश्चन बुरा है, बहुत अच्छा क्वेश्चन है, रिसर्च कर रहे हैं इस पे। इररेलेवेंट है, ठीक है। व्हाट वाज द मीडियम बिफोर सिंगुलर, बिफोर बिग बैंग? इररेलेवेंट, दे वोंट आस्क यू। सिंगुलैरिटी के बारे में उन्होंने सबसे बड़ा क्वेश्चन जो अभी तक पूछा है वाज, इफ आई एम राइट, द स्टेट, नेम ऑफ द स्टेट, बस इतना ही पूछा है। इसके बियॉन्ड वो जाएंगे भी नहीं, इसलिए क्योंकि सिंगुलैरिटी वाज नॉट देयर ओनली देन, सिंगुलैरिटी इज आल्सो फाउंड इन ब्लैक होल्स, इसलिए पूछा है कुछ, ठीक है। बट उससे ज़्यादा वो पूछेंगे नहीं, क्योंकि उसका मीडियम एक्सप्लेन करने के लिए अभी रिसर्च ही चल रहा है, तो ज़बरदस्ती क्यों हाथ डालें, ठीक है। तो ये जो मीडियम का आपका पहला क्वेश्चन था सॉल्ट, सेकंड क्वेश्चन का क्रक्स बोलो, इतना स्टोरी मत बताओ प्लीज। जैसे आपने वहाँ सिंपल बोल दिया ना, सर व्हाट वाज द मीडियम फॉर सिंगुलैरिटी, मैंने बोल दिया इररिलेवेंट, राइट, बिकॉज वी स्टिल डोंट नो।
universe is expanding in which medium?
Universe is expanding in which medium? We don't know. ठीक है, because then there is another concept of multiverses, ठीक है, and levels of universe. Out of course है, यूपीएससी ने कभी कोई क्वेश्चन नहीं पूछा, छोड़ देंगे, ठीक है। अगर पढ़ना है क्लास के बाद में लो, बुक दे दूंगा, राइट, लेकिन अभी नहीं बात करना। यस,
सर जैसे सर अर्थ का बिफोर कोलिजन नेम गाया था, हमारी स्टार का सुपर मतलब
उसका नाम आई डोंट रिमेम्बर, इफ यू गूगल यू विल फाइंड, राइट। मेनी टाइम दे कॉल इट एज द प्रोटो सन, समथिंग लाइक दिस, right? Not even proto sun, they call it the star before sun. They do have some name but not relevant. Actually वो उतना जरूरी भी नहीं, ठीक है। मैंने ऑलरेडी थोड़ा सा स्ट्रेच करके आपको बता दिया है कि there was a star, and most of your sources you won't find this mentioned, mostly, ठीक है। Anything else? पक्का? बुरा तो नहीं माना ना? पक्का ना? ठीक है, गुड। मान भी लोगे तो मुझे फर्क नहीं पड़ता। रीजन बीइंग इमोशनल नहीं होना है, सीधी सी बात है यार, मेरा काम ही यही है, ठीक है। मैं आपके इमोशंस के साथ मतलब बह नहीं सकता हूँ, आप बह सकते हो अभी, राइट। तो मेरा काम है आपको ये बताते रहना कि कहाँ पे रुक जाना है, ठीक। तो have some doubts? Oh yes. After death of star procedure, please tell. After death of star procedure, please tell. We would do in the last class, Shipra. So right now I won't answer. Okay, we would do in the last class because I did tell that the life cycle of the star would be done later, either in science or in my last class. Is that the only question? That's it? Right. Good. So now let us start with Earth, and we had talked the कुछ बोले आप? Okay, so we have talked of the volcanic state of the molten Earth. This is where we were, I believe most of you remember, and we had talked led to emitting gases. In this we wrote the ammonia, methane, CO2, etc. formed what, first or second? Second atmosphere. Okay, that's exactly where I left, and we were to talk of the second thing, which was the steam, right? Steam, gaseous H2. Now what did this gaseous, so this is exactly where we start from. Is this okay? ठीक है ना? And the earth was molten and boiling and all that. ठीक है? In the volcanic state. So the steam gaseous H2O, what did that form? If you have steam, okay, for example, if let's say a lot of steam is released in the atmosphere, what would that steam or that vapor thing go and form ultimately? They might rise, right, to a certain height, and there they might go on to gradually condense, right, and form clouds. Okay, and have you felt cloud-like thing in your real life? This is the season. Fog is the equivalent of cloud. Okay, it is equivalent. It's the same thing. The only difference is fog is on the ground floor and cloud is on the top floor. Okay, or the higher floors. So when the same thing happens at a higher or at an altitude, we call it as cloud, and the same phenomena close to the ground where we exist, if it happens there, we call it as fog. So fog and cloud are same things, and this is something that you experience when you go in an aeroplane high up in the air. So when an aeroplane is passing through the clouds, you feel like fog, that you are surrounded by same fog-like phenomena. Is that okay? So this is how the clouds are formed. Now, because the Earth's surface was too hot, so you couldn't get fog, because fog forms in the colder places. So Earth's surface was extremely hot, so we didn't get fog, but we did get clouds, right? So the steam which was released turned into clouds, and gradually it created a good amount of clouds in the sky, right? Now the process that I'm talking of, and keep one thing in mind, in geography when we say sometime, it generally means millions of years. Okay? When we say very soon or quickly, it can mean something like 10, 15, 50,000 years. Geography का time frame ऐसा चलता है. ठीक है? Is this clear? So when I say this happened for few years of some time, I didn't say years, I would say some time. It would mean it would happen for few lakhs of years or millions of years. So this emission of steam kind of a thing and formation of clouds would continue for few million years. Okay, so starting from, you can say 4.44 million years, for a few million years or tens of million years, this went on, right? And these clouds, once they are formed, and once the earth is, let's say, having a lot of clouds in its atmosphere, what is the next thing that would happen? Gradually the clouds will lead to some kind of precipitation. Precipitation means rain. Not precipitation means lot many other forms also, like snowfall, etc. But here it would be rain. So because of the clouds, we started getting rains. Now your question could be, sir, where did the water go? Because the earth's surface was hot and molten. That's perfectly fine. Maybe the initial rain fell on the surface and evaporated again and again formed cloud. And gradually, because the volcanoes were also throwing more and more of steam, so more and more of clouds. Over a period, what would happen? That the precipitation would go on increasing, right? Evaporation will also continue. Over millions of years, the earth's surface was also gradually getting cooled. Okay, because initially the earth was hot, gradually it was cooling. So over millions or tens of millions or hundreds of million years, the earth would get cooled down. So the surface was gradually cooling on its own. One, the precipitation that was happening, that was also cooling the surface. Two, the amount of precipitation was increasing. So the evaporation was not as much as precipitation. So the rainfall amount increased and the evaporation did not catch up. It gradually decreased. So what will happen now? Now you will start getting a layer of water on the surface, right? And when the whole earth's surface is covered with water, what will you call that water body as? Ocean. That's what oceans are, right? So this is how the oceans started developing, thanks to the clouds. Do we get it? So first we got the second atmosphere, in that those gases, then steam, clouds, precipitation, and because of those precipitation, because of the precipitation, we started getting a layer of water on the earth's surface, which gave us the first oceans of the earth, right? And from 4.44 billion to 4 billion. By 4 billion years before present, which is approximately 406, 360, any 4.44 है ना, so 440 million years. Over a period of around 440 million years, this process continued. And by 4 billion years before present, we already had our first global ocean. So now we had the atmosphere and we also had the global ocean. Do we get it? So now you have two things formed. Initially it was just the hot molten earth, and now you have the second atmosphere and you also have a global ocean. And what is the state of surface below the global ocean? क्या लग रहा है? What should it be? Molten, that's okay, and gradually cooling. Now is it possible to have molten lava below water? Is it possible or no? It is possible. How do you come to know? Because presently also there are many volcanoes which are taking place on the ocean surface. Volcano is still taking place on the ocean surface. It's not that volcanoes take place only on continents and islands. Volcanoes are still taking place on the ocean floor presently. So the magma will just come out, it will spread, and it will cool down faster because of the water. But initially it would spread as molten lava only, right? Red hot molten lava. वैसा ही होता है. Is this imaginable? Clear? Yes or no? Right? So what did we get? We get the second atmosphere, we get the global ocean, and below that we have broadly the layer of molten lava. Is this okay? So the second, the ocean was formed in this way. I'll dictate all this in the end, don't worry. Okay, first understand the sequence. Now, so what, yesterday we wrote 3-4 things. The atmosphere part done, right? Ocean also done. Now we have to come to land. So first we have to understand how did land below the ocean form, because we wrote two pieces of land, one above the ocean, second, दो लिखा था कल हमने, है ना? So above the ocean and below the ocean. So first the land below the ocean was formed, and later on the land above the ocean was formed. So first let us understand how did we get the land below the ocean, right? And right now what do we have below the ocean? We have the molten lava. So how did this molten lava turn into land? Not a very complex story, simple thing. I generally give this example of milk or tea or Maggi or whatever boiling pot. I believe most of you must have seen how when you cook Maggi or tea or boil milk, what happens? You have that boiling pot, and in that you put that liquid, and then you put it to a boil, and the flame is high, right? And because the flame is high, you have multiple boiling pots in the multiple boiling points in the pot. वैसा ही होता है ना? Something like this. This is your liquid, and you have multiple boiling points on the surface. So the liquid is rising and it is boiling at a lot of places. This is the flame. Okay, something like this. So this way you have a boiling pot, right? The earth was also a boiling pot with the molten lava coming up. ठीक है? Imaginable. So gradually when the flame of the boiling pot is reduced, let us say over a period you start reducing the flame of the boiling pot. Initially you will see lot many rising spots. That is like the volcano. Volcano वही होता है ना? It's just the scale is big, right? If you put a ant at the edge of that and ask उसको क्या दिख रहा है, वो बोलेगा volcano. गिर गए तो boil होके निकलेंगे, right? So I hope it is imaginable. Now when the flame or the surface or the object which was heating it up starts getting cooled, what do you observe first on the top? You start observing a layer of solidified cream. Yes or no? Or whatever is light which was boiling up and rising, it starts to form a layer of solidified, semi-solidified kind of a thing. सबने देखा है, right? The same thing happens on earth also, right? From inside things are boiling and rising, and if I ask you what do you think is the density of the material which solidifies on the top of your teapot or the milk thing or the Maggi thing, what is the density of the top solidified layer? Is it denser than the liquid below or it is lighter than the liquid below? What do you think? How many of you say lighter? Okay. And how many of you say denser? Denser than the liquid below. That's what I'm saying. If it was denser, do you think it will float on top? आपने तो बॉयंसी और आर्किमिडीज को पानी में डुबा के मार दिया, जिसमें से वो निकल के यूरेका चिल्ला के भागा था. Why do things float? Because they are lighter. So the cream is lighter than milk. Huh? Is it lighter than milk or no? The quantity varies. Acha, lighter for digestion, am I asking? You know, lighter for digestion or lighter by density? What am I asking? लोग बोलते हैं ना क्रीम नहीं खाना चाहिए, हैवी होता है ना, मिल्क पी लो क्रीम निकाल के. तो आप लोग के पास कौन सा आंसर है? यस बोलो. सरफेस पे. Is it because of the surface tension that the cream is floating? अच्छा ठीक है, let me take away the cream. The cream is made up of ghee or oil. So if I put a chammach of ghee on top of milk, will it sink or will it float? किया है. पहला ये बोलो, या बचपन से जब से पैदा हुआ है तब से आईएएस की तैयारी कर रहे हैं? बहुत सारे होते हैं, सर हमने जिंदगी में कुछ नहीं देखा, हम जब से पैदा हुआ है बुक लेके ही पढ़ रहा है, इधर उधर देखा ही नहीं. रियल लाइफ में थोड़ा इधर उधर देखना है. आज जाके मिल्क बॉईल करना है, ठीक है? नहीं हो तो मैगी. ये मत बोलना सर हम गरीब लोग हैं, मिल्क किधर से लाएंगे. मैगी तो होगा 10 रुपए का, ठीक है? तो मैगी बॉईल करना है, ठीक है? और उसको देखना है क्या होता है. कोई पूछेगा क्या कर रहा है? अर्थ का सरफेस फॉर्मेशन समझ रहे हैं, ठीक है? सब बोलेंगे पक्का यस बनेगा. इसको मैगी में भी अर्थ दिखाई दे रहा है, ठीक है? सी व्हाई आई एम सेइंग दिस इज बिकॉज द प्रोसेस, देखो एक बिल्कुल सिंपल सा रूल याद रखो. यूनिवर्सल लॉज अप्लाई एग्जैक्टली द सेम. दे डू नॉट डिस्क्रिमिनेट, राइट, ऑन द बेसिस ऑफ साइज. ऑन द बेसिस ऑफ साइज जब लॉज डिस्क्रिमिनेट शुरू होना होते हैं, वी कॉल देम एज क्वांटम फिजिक्स. ओनली एट क्वांटम लेवल द लॉज चेंज, ठीक है? So that physics is called as a different physics. We call it as the quantum physics. All the other, right, and that is at a very small level, quantum physics. ठीक है? So at your normal level, the laws of nature remain same. That's why I am asking you to imagine that boiling teapot, because obviously boiling earth surface you have not seen, so I can't ask you to imagine. But teapot तो सब नहीं देखा है, and the laws will be same. ठीक है? So that's why. So now let me give you clarity, because some of you might not be very clear what is lighter, what is denser, and don't believe me, go home, take a spoon of ghee, melt it, put it on milk and see whether the ghee is denser or the milk is denser. ठीक है? The ghee will float on top of milk. Why? Because it is lighter in density. Same ways the cream is lighter in density. Is this clear? Another way to understand this is, you take a bowl, put cream in it, and then fill it with milk. That cream which was at the bottom initially would start floating on the top. That shows that the cream was lighter. So don't go by state. You think it is solid, so it must be denser. Wood is solid, na? It floats on water. Thermocol is solid, it floats on water. So it's not necessary that something solid has to be denser also. We have some misconceptions in our mind. हम उसके साथ ही चलते रहते हैं, ठीक है? So वो भी हमें gradually correct करना है. Is this clear? So when you take that milk, and in that I hope you understand, on top the layer that you get is made up of lighter things which gradually solidify because now they are in contact with a colder atmosphere. That's why the cream solidifies. ठीक है? Same ways on the earth surface, from inside the rocks etc. and everything was rising up, and it was a mix of denser and lighter material, right? So when these things came on the surface and they came in contact with the water layer on top, or even if the water layer was not there, let us say they came in contact with the atmosphere, they would start cooling. When they will cool, the lightest molten rocks will start, or not the lightest, we can initially say the light molten rocks started solidifying. So below the ocean surface, the way cream solidifies in your boiling pot, same ways the light rocks started solidifying and creating a layer of rocks. That layer of rock is what you call as the ocean floor. That's how the ocean floor was formed. And even now, if you dig deep into that ocean floor, you will go to a region which is molten. Right? Anywhere on the earth, if you go deeper, beyond a certain point, you will come to a region which is in a molten state. Okay, so only the top layer is solidified. Okay, whether it is above the ocean or below the ocean. Right now we are talking of below the ocean, right? So what was happening? Atmosphere, ocean layer, below that molten rocks, volcanic activity. Thanks to volcanic activity, lighter material was rising close to the ocean surface, right? Or below the ocean, this thing. And there it was getting cooled down, and that led to the formation of the first rocky layer. We call it as the ocean floor. And what is the ocean floor made up of? What type of rocks? Light or dense? Light, right? So the ocean floor is made up of light rocks. When you go deeper into the earth, you will come across more denser magma, right? And as you will go to the center of the earth, you will find the densest material at the center. Is that okay? Because the earth's gravity is stronger than the earth's rotational centrifugal force. Therefore, on the earth, the lighter is outside and the denser is. Why? Because the gravity of the earth is stronger because of its mass as compared to the rotation of the earth. If the earth's rotation was very fast, then maybe the denser would have been outside and lighter would have been at the center. Okay, because then centrifuge would have overcome gravity and it would have thrown things out. Is this okay? So because the earth is rotating slow, what is the speed of rotation of the earth? One rotation in 24, nearly 24. One day we do one rotation. So that is relatively slow, because of which the gravity is able to attract all the dense things to the interior and throw the light things out. See, atmosphere is light. Then you have water bodies, slightly dense. Then you have rocks. Those rocks are also light rocks. As you go deeper, you will come across more denser rocks. Is this clear? पक्का? आपको भी clear है? पक्का? ठीक, नींद तो नहीं आ रहा है ना? ठीक है, आगे बैठ के मत सोना यार, है ना? ड्राइवर के साथ वाली सीट पे सोते नहीं हैं, मुझे भी नींद आ सकती है फिर. So clear? Good. So what do we form? What did we get from this? Led to emitting of gases, that led to steam, and steam led to, let me just make a flowchart here which you can also draw. Steam cooled, sorry, steam led to, yes, so cooled, formed clouds, and clouds led to precipitation, that is rains, led to, and rains led to global oceans. Okay, global oceans. And so this was the ocean part. Then apart from gases, what else came? Led to emitting gases. Then molten earth emitting molten lava below global oceans. Is this much clear? है ना? Rains, global oceans, And on the other side, so gases gave us up to global oceans. Thanks to gases, we got the global oceans because steam, precipitation, and ocean. Is this clear? And then the other thing which comes out at the volcano, apart from the gas, is the molten lava. What did the molten lava give us? That's what we have to do. Where was the molten lava coming out? Below the oceans, right? So below the global oceans, molten lava below the global oceans cooled and solidified, forming solid light rock layer called, what do we call this solid light rock layer? Called ocean floor or sea floor, or we also call it as oceanic crust. Oceanic crust. Okay, clear? Oceanic crust tak ka story hopefully we understand. Right now I'm just giving you the flowchart. I will dictate all this at the end. Once I have completed the story up to continents, then I'll dictate it. Clear? ठीक है. So this is your whole flow chart approximately. Right? Gases here and molten lava here. ठीक है? कौन सा पार्ट चाहिए जूम? इतना ठीक है? हाँ? जूम इन जूम आउट अभी ठीक है? ठीक है, लिख लो. And we'll go on writing on the side what all we have formed. So we have discussed first atmosphere, second atmosphere, clouds and rains and global ocean and ocean floor and ocean rocky floor. This much we have done. Rocky ocean floor, we should have written that way. Rocky ocean floor. Itna clear hai? Now what is still to be formed on the earth? The earth that you know. Abhi kya kya bacha hai? The continents and the islands, one, and second, life. And one more thing we have to change, the atmosphere, right? The atmosphere that we have done is a very intoxicating atmosphere. We have to come to this livable or life supporting atmosphere. So this part of the story we have to now cover. Okay, how did we reach up to this? Now, by when was the ocean floor formed? This was also formed by 4 billion years before present. So the ocean and the ocean floor both were already formed by 4 billion years before present as per your NCERT. We are going as per your NCERT. Okay. So ocean floor was also formed by 4 billion years before present. Even the continents were formed by then. Okay. But I have to tell you the story of continent. So should we talk of the continent part? Itna clear hai na? As I said, I'll dictate in the end. Don't worry. Right? We'll spend 2-3 minutes. I'll dictate the whole sequence. So now, how did we get the continent? Now, now that you understand that the oceanic floor is made up of light rocks over the molten magma, which is denser, the continental rocks, what do you think? They should be lighter or denser than the oceanic floor? Lighter. The continental rocks are a grade lighter than the oceanic floor rocks. The oceanic floor rocks are called as basaltic rocks. This word you might have come across when you read your NCERT. Basaltic rocks, and basaltic rocks are denser. This data is also given wrong in your NCERT. The density of ocean floor is given lighter than the density of continental rocks. The density of ocean they have given as 2.7 grams per centimeter cube. The density of continents they have given 3 grams per centimeter cube. This data is interchanged by mistake in NCERT because they have copied. तो कॉपी भी करेक्टली नहीं कर पाए, RNA के जैसा कॉपी किया है ना, प्रूफ रीडिंग नहीं होता है. दैट्स व्हाई दिस वायरस इज म्यूटेटिंग सो मच. ठीक है, सो वैसा कॉपी मार दिया है, राइट. सो वन थिंग यू हैव टू डू इज गो बैक एंड करेक्ट दिस डेटा. द ओशियन फ्लोर इज 3 and the continent rock density is 2.7. The continental rock is said to be made up of andesitic type of rocks. Okay, the continental rocks are andesitic type, right? Whereas the acidic andesitic type continental rocks, whereas the ocean floor rocks are basic basaltic type. Okay, this you can write on the side somewhere. अभी भी लिख सकते हैं अपने कॉपी में, right? That the continental rocks are more lighter. Continental or island rocks are more lighter continental rocks are more lighter, made up of lighter acidic andesitic, lighter acidic lighter acidic andesitic rocks, lighter acidic. This is for continental only we are writing ना, ऐसा देख रहे हो आप मुझे, where I have dictated because I was reading the question, so I slightly I think. Yeah, so the continental rocks are made up of lighter acidic andesitic rocks, and the oceanic floor rocks andesite, A-N-D-E, Andes, the name comes from Andes mountain, A-N-D-E-S-I-T-I-C, A-N-D-E-S-E-T-I-C, andesitic rocks. ठीक है. Whereas the ocean floor rocks are made up of denser basic basaltic rocks. Okay, so you have two types of rock, the continental or the island, acidic, lighter and andesitic. We call it as andesitic, A-N-D-E-S-I-T-I-C, andesitic rock. Whereas the other rock is the ocean floor rock, which is basic, basaltic and denser. Is this okay? So अभी हमको dense और light के ही terms में जाना है. Those names are not very important right now. Names you will understand, don't worry. वो सब हम करेंगे. When we'll talk of the lava type, I'll again give you all those terms. Right now just understand oceanic floor rock is denser and the continental rocks are lighter. ठीक है? So where do you get these continental rocks from? Continental rocks also come from deep inside only. ठीक है? Now let me tell you how it is. So you can imagine the molten lava which is coming from deep inside, or the molten magma which is coming from deep inside, to be a mix of lot many minerals, right? Because all the minerals inside the earth are there in that mix. Okay, so you will have the densest minerals, you will have the dense mineral, you will have the light mineral, and you will have the lighter mineral. Okay, and then you might have the lightest, which is the gases. So what was the gas? What was the lightest which was coming out of those volcanoes? The gas that formed the atmosphere and the ocean. That was the lightest material. After that you have the lighter material and the light material and the denser material. Okay? The denser material keep going down. The light material had already formed the ocean floor. Now you are left with one more type, lighter material. right? That is the lighter rock material. Okay, and that is a mix. So because the whole thing is a khichdi kind of a thing, so when the heating brings it up, though the lighter and the denser separate, but they do not separate properly. Okay, for example, if you take, let's say you take flour, right? The flour from which you make chapatis. In that you put water, and then you put ghee, and you put some oil also, and you put some dense heavy raisins or whatever, and you mix the whole thing, right? And you put it in the fridge, so it is cold. You take it out and you start putting it in the microwave or start heating it up. What will happen? First of all, steam will come out, right? So heating has the capability to segregate things on the basis of density. Okay, because different dense things heat up at different temperatures. So this is what heating does. Heating separates different density things, right? That's why when you heat up that dough, first what will come out? The water. Then you might start seeing some oil layer on top, right? Which means the fat from that whole thing is now coming, melting and rising. Okay, and then gradually that atta will also become soft. I hope it is imaginable. Can you? So what is heating done to it? Segregated. The same happens in milk also. When you get the milk from the source, raw milk, the cream and the milk is mixed. When you heat it up, what is heating doing? Heating is separating the milk from the fat. That's why the cream layer segregates and accumulates on the top. Okay, so heating, when you heat up something, the different density things in it start getting separated. Simple. Same is happening inside the earth also. So because the lava is getting molten, or the magma is molten, so the lightest, lighter, light, dense, denser, everything will gradually segregate. So in the first go, when the magma came out, it could throw out what all? The gases and the light rocks which form the ocean floor. Okay. So imagine this way. Suppose this is the magma layer inside the earth. On top of that, you have this thinner layer of ocean floor. Right, this is the ocean floor rock. Okay, something like this. And there is no gap. This is just my drawing thing, because of which some gap seems to be there, but just imagine there is no gap in between. Something like this. So this is what? Ocean floor. Rocky ocean floor. And above this, what do I have? Above that rocky ocean floor, we have the oceans. This is the ocean water. And if you want, you can draw. Okay, that's the ocean. Ocean, and above it you have the atmosphere. Something like this. That's your atmosphere. Okay, over the ocean. Right? Because now I'll zoom once we have drawn this. And as you go inside, you have the dense magma. Inside is dense magma. All is dense magma. Okay, something like this. Okay. Let's draw this, then I'll tell you what I intend to. So the atmosphere, and the atmosphere is made up of the lightest gas, emitted material. The ocean is also made up of lightest, which has the steam which gradually led to, so steam also came out as light only, but then it condensed and turned into rain and led to creating the ocean. Okay, so obviously it is slightly denser than the atmosphere, but it is still made up of the lightest, the ocean part. Then what do you have? You have the rocky ocean floor. This is made up of light rocks, light rock material. Okay, and the magma inside, magma is dense rock material. Okay, ठीक है, very good. Now you have to form the ocean, the continents. So where will the continents form in this diagram? The continent will form at the margin of the ocean floor and the we can say somewhere here, something like this. This is what the continent or the islands will form like, right? Over the ocean floor, below the atmosphere, next to the ocean. Yes or no? That's what your continent or the island is like. So this is your island or continent rocks. ठीक है, that's how it is positioned. पक्का ना? No major doubt. Which also means, because this island, and sir, is the island formed over the ocean floor? If you ask me that question, the answer is yes. All the islands or all the continents are formed over ocean floor. It's just that between the island and the ocean floor there is no water. ठीक है? So the continents or the islands grow over the ocean floor only. ठीक है? They just vertically grow above it. Clear? So what should be the density of these rocks as compared to the ocean floor rocks? Lighter. So now we have to understand, where did these lighter rocks come from? Do they come from the inside directly? The answer is no. Do the lighter rocks of the continent come from the deep molten magma directly? The answer is no, it doesn't come. Where does it come from? For that I'll again take you back to that boiling pot, milk wala boiling pot. Should I? Now just imagine, when the flame is slightly low, first of all, is this much drawn? Anyone is still doing this? No? Very good. So when the flame is slightly low and you already have a layer of cream, right, and just imagine on that layer of cream you also have some leaves and some cardamom and some cloves and something which is part of that cream layer. Why? Because the mix didn't segregate properly. Over a period, if the heating is still continuing, that cream layer on its margin starts to melt. देखा है? That cream layer which is formed, if you keep boiling it, the cream layer, and if the heat is still not very cold, the cream layer on the margin again starts to melt and sink. And when it melts and sink, whatever those smaller other things which were there on that cream layer, they also melt and sink. And next time, those lighter things will come out separated somewhere else. Imaginable? इतना अच्छे से सर हमने कभी बनाया ही नहीं. चाय बनाया, पी लिया, कहानी खत्म. इतना कौन समझता है चाय में? आज करो एक बार and put a few things and see. ठीक है, मैं अभी भी जब भी चाय बनाता हूं तो मैं यही देखते रहता हूं क्या क्या बाहर निकल रहा है. ठीक है, because that helps me understand the process better, right? So is it okay? So what will happen? Now this time what has to go back? These ocean floor layers is like that cream. So this ocean floor layer tends to sink back into the molten magma. It sinks back. It breaks and sinks back at different places. The ocean floor tends to break and sink back. So first the ocean floor will form, then it will again break, then it will again sink. When it sinks, now because it was made up of light material but not the lighter rocks, because the lighter rocks were already mixed in it. So what will happen is, over a period, this ocean floor, with the sunken ocean floor, will also start to melt, and from this the lighter parts will rise and the denser parts will sink back. So second time segregation. The first segregation gave you the oceanic floor. The second segregation gives you the continental floor material, right? And whatever denser rocks were there in that oceanic wala part, they will tend to go back into the Earth's interior. So it is a two-time process. Ocean floor is formed in the first cycle. The continental floor is always formed in the second cycle. The way the planetary star was always formed in the second cycle. The first star didn't give you planet. किया था ना आपने? Same ways here also. So can we get directly the continental material from the deep inside? No, we never get. Who tells you? The volcanoes. When we go and check the magma at the volcanoes which are directly coming from deep inside, we always find that they give you basaltic rocks. And where we find that the oceanic floor has broken, gone down, melted and come out, there we see that the magma which is coming out is not basaltic. It is the lighter andesitic magma. Okay? So the earth itself is telling its story through evidences. Okay, simple evidences. So what will happen now? When this will go up, this thing will come up and it will tend to solidify. And when it solidifies into a relatively vertical formation over the ocean floor. And vertical, so it will go on rising. Initially when it is below the water level, we might call it as ridges in the ocean, right, or peaks in the ocean. And gradually when it come above the water, you will see it as land. If it is small land, you call it as island. If it is a big land, you start calling it as continent. And continent might form, generally they do not form as big land in one go. You might have many islands, and each of the island grows and then they attach with each other. So when islands go on to grow and attach, they tend to form continents, right? There is one more thing which forms the continents, the moving islands, because most of the islands are also moving. That you will learn in plate tectonics. Okay? So because they move, so they go hit another island, join. Maybe another island will come, hit, join. Once the land becomes big enough, you start calling it as, that's it, that's the story. Clear? So is this understood? Any major doubt? When the oceanic crust sinks down after breaking and then melts. No. It's not the conversion. Basically, the material which has risen in the first go, which gave you the basaltic rock, already also had some andesitic rocks in it. It was still a mix only. Okay? It was still a mix, and gradually the silica content, because silica is lighter, kept on increasing. Okay, and the other magnesia, all that was light, denser, it sank. So when you see the basaltic rock, that's why I'm not getting in the composition right now. You will understand over a period. It's the composition, right? So basically it is the material and the composition. When you say the andesitic rock, they are richer in silica, which is light. When you say the basaltic rock, they are richer in magnesia and iron, etc. Okay, richer. It's not that very different. They are just richer. One is rich in silica, that is lighter andesitic rock. The other is rich in magnesia, that is the denser basaltic rock. Is this okay? ये सब बाद में बात करेंगे. That was just to him. अभी आप छोड़ दो. Because I will come to that when needed. अभी नहीं बताता हूँ. अभी चाहिए नहीं हमें. ठीक है? Is this okay? So did we understand? Sir, how does it segregate? I can give you an example. You take a chocolate bar in which there is lot of nuts. आता है ना आजकल बहुत सारा वो ground nut वाला chocolate, sneakers or something in which you have nuts. You take it and you put it in a boiling water. ऐसा लटका दो उसको. what will happen? It will start melting. Once it melts, where will the chocolate and all rise? Gradually the lighter parts will rise and the denser nuts will sink to the bottom. So you can imagine the ocean floor like the sneakers, in which lot of mix is there. Okay? And when it melts, it throws up the lighter ones and sinks down the denser ones. Clear? समझ गए? Good. So in this cycle where we had formed the oceanic floor, let me also add up molten lava below the global ocean and then this oceanic crust, and now where you have written this oceanic crust, you can write further. The oceanic crust breaks and again sinks and melts, right? This oceanic floor or crust breaks and again sinks and melts, segregating lighter andesitic rock material, lighter andesitic rock material from denser material. Okay, lighter and segregating lighter andesitic rock material from denser material. Then next part will be talking of this lighter andesitic rock material. I have to write about it, but इतना पहले लिख लीजिए. Okay. Okay. So the oceanic floor breaks and again sinks and melts, segregating lighter andesitic rock material from denser material. Now what happens to this denser material? Denser material sinks back into earth, sinks back deeper into earth. Okay, so the denser material sinks back deeper into the earth, and what happens to this lighter andesitic rock? Again rises as lighter rock, magma, and forms continental or smaller island rock formation. Continental or iron rock formation. That's just to complete your flowchart, right? Many of you might be comfortable with this flowchart and don't need to write it in dictation. That's okay. I'll again be dictating for the ones who still want a dictation, because I do keep getting the requests that sir please dictate also. हमें समझ में नहीं आया लिखने से. ठीक है. So जिसको इतना कंफर्टेबल है, गुड इनफ, मत लिखो, पढ़ लो, रिवाइज कर लो. जिसको क्लियर है, ओके, नहीं है, लिख लो. ओके, is this much clear first of all? Any doubt? So do you understand how did we get the continents? ठीक है. And when were the continents formed? As per your NCERT, they were also formed 4 billion years before present. The sequence remains as we have done, but all these formations were already done in those 440 million years. So after that big splat, in the 440 million year, everything was formed. Second atmosphere, ocean floor, oceans, continental floor, everything was already formed in the 440 million year. बहुत कम time नहीं होता, it's a huge amount of time. ठीक है? Is this clear? So do we get it? Clear? Now should I dictate? लिख लेते हैं, कोई बात नहीं, कोई बात नहीं, एक दो बार लिखते हैं. वंस यू पीपल स्टार्ट गेटिंग कंफर्टेबल, अपने आप बोल दोगे सर मत करो डिक्टेट, दैट्स गुड इनफ. ठीक है. सो दिस इज द डिफरेंस इन योर ज्योग्राफी क्लासेस, बिकॉज यहाँ पे ना ये मतलब इट्स नॉट लाइक, एज आई जनरली से, इट इज नॉट लाइक हिस्ट्री की सिर्फ डिक्टेशन चाहिए. यू नीड अ फ्लो चार्ट काइंड ऑफ अ अंडरस्टैंडिंग ऑल्सो ऑफ थिंग्स. पैराग्राफ से काम नहीं चलता. इन योर आंसर्स ऑल्सो start making flow chart of things so as to segregate and make visible for the examiner. ठीक है. diagrams, flow chart, they help you in getting more marks, right? So लिखिए. I think yesterday I had said up to, did I dictate that part, the first atmosphere part yesterday? वो तो हमने लिख लिया है ना. first atmosphere was formed and lost due to the solar winds, वो सब हम लिख चुके हैं. ठीक है. and then we had the big splat, वो सब भी लिख चुके हैं. and then the earth was hot molten. I think hot molten पे हमने छोड़ा था. so let us write from there. ठीक है. so now this is the dictation of what all we have done today, right? तो अभी मैं भी बैठ सकता हूँ. oceanic crust to break and sink. What makes the oceanic crust to break and sink? This we'll do. There's a question by Renu. What makes the oceanic crust to break and sink? This is something that we'll do in plate tectonics. Don't worry, Renu, it's coming. Okay. So write down the numerous. What is the heading? इसका एक सब heading में लिख लीजिए. Formation of second atmosphere, ocean. Formation of second atmosphere, ocean floor and continents. Ocean floor and continents. Okay. Now right under it, there were numerous volcanic activity on the surface of hot molten earth. Numerous volcanic activity on the surface of hot molten earth, where gases and hot molten rocks were rising. Where gases and hot molten rocks were rising. Full stop. Next paragraph. Underline gases and hot molten rocks, because we'll be talking of these two now. ठीक है. First, next paragraph, the gases within bracket, methane, ammonia, CO2, etc. Gases, methane, ammonia, CO2, etc. plus steam led to formation of the second atmosphere, which now was made up of relatively denser gases, hence did not escape the earth, which was made up of relatively denser gases, hence did not escape the earth. Full stop. This second atmosphere was highly intoxicating. In nature. Poisonous. Okay, highly intoxicating or poisonous in nature. Right? Full stop. The steam condensed, write this way, the steam condensed and led to the formation of clouds, which led to millions of years of rains which led to millions of years of continuous rains. Millions of years of continuous rains, and hence gradually a layer of water blanketed the whole earth. Blanketed, covered, right? Blanketed the whole earth, which we call as blanketed the whole earth, which we call as the global oceans. The global ocean. Global ocean. Full stop. So now you have the second atmosphere. Underline second atmosphere and global ocean. These two words you have written. Second atmosphere and global ocean. ठीक है? Underline it. Now come to next paragraph. The molten rock material, the molten rock lava material, molten rock lava material rising at volcanoes, molten rock lava material rising at volcanoes was bringing up relatively light rocks, relatively light rock mix. You use this word here, relatively light rock mix. It was not pure, it was a mix, but it was a light rock mix. ठीक है? Relatively light rock mix, which gradually cooled, shrank, wrinkle, right? Wrinkle like shrinking, right? When something cools, it creates wrinkle. वो जो मलाई होता है, देखा उसको कभी ध्यान से, उस पे भी wrinkle बने होते हैं, because it shrinks and creates wrinkle, right? Shrank and wrinkled, shrank and wrinkled, forming parts of a layer of rocks below the global ocean. Below the global ocean. Full stop. Gradually this grew to cover the whole earth. Gradually this grew to cover the whole earth below the global oceans. Gradually this grew to cover the whole earth below the global ocean. And is known as ocean floor or oceanic crust. Below the global ocean, and is known as ocean floor or oceanic crust, right? Or sea floor also, as we have written earlier. Underline these names. Also, next paragraph. The seafloor rocks, though light, the seafloor rocks, though light rock mix, yet are not the lightest of the rocks, right? Not the lightest of the rocks. Not the lightest of the rocks. Full stop. Hence Hence, these rocks again sank. These rocks, seafloor rocks or seafloor layer, right? Hence, this seafloor layer again broke and sank. You write this way. Again broke and sank. Sorry, I'm adding words. ठीक है? This seafloor layer again broke and sank. S-A-N-K. Sank back. Right? Sank back into the ocean. Into the molten lava below. Sank back into the molten lava below. ठीक है? So this is the sinking of the ocean floor, right? Broke and sank back into the molten lava below, where it further melted and segregated. Sank back below, where it further melted and segregated. I gave you that example of that chocolate bar, sneaker wala, वैसे, ठीक है? Where it again sank back, where it again melted and segregated further into lighter acidic andesitic rock lava, lighter andesitic acidic rock lava, which again erupted as volcanoes, and solidified to form islands or continents. Solidified to form islands and continents. Within bracket, relatively vertical solidification. That's how it will rise above the ocean, right? Relatively vertical solidification, right? So this andesitic thing, when it came up, it solidified relatively vertical. It didn't solidify spreading. If it will spread, it will form seafloor. That's the basaltic one. I didn't tell you there, don't worry. You don't need to go into that. But this thing, the second magma which came out, which was lighter, solidified relatively vertically. Why? I'll talk of that later again. Okay? So it just solidified vertically, and because of that, it grew over the oceans. So it could emerge above the water. And then once it has emerged above the water, that's what you call as the land or the island or the continent. Had it spread in below the ocean water, it would have again formed ocean floor. Okay, but that's not the nature of the lighter rock. Lighter rocks tend to solidify relatively vertically. Why? I'll tell you. Is this okay? Okay, is this clear? So now do you have the continents also? Right? And what happened to the segregated denser material? वो जो आपने लिखा है अभी ऊपर, further segregated into lighter and denser. So the lighter one rose and formed the continent. What happened to the denser material? Sank back. If you want, you can write this. If you think कोई बात नहीं चलेगा, उससे हमें कुछ ज़्यादा मतलब नहीं है, that's also okay. ठीक है, but if you feel like, you can write this one line. After that last segregation, after this last segregation written above, the denser material tends to sink back into earth. Last segregation written above, the denser material sinks back into the earth. Okay. Now by this process, basically what is happening on earth? Earth is segregating the lighter from denser continuously, and it is throwing out the lighter and it is attracting in the denser. And when will this process end? What do you think? Is this process still continuing? Who tells you, or what tells you? The volcanoes. The volcanoes are telling that this process is still continuing. And when will it end? Once either the segregation is completed or the gas is gone. Burner बंद कर दोगे तो भी तो चाय नहीं बनेगी ना. So either the heat has to get over inside the earth or the segregation has to complete. then only this process will end. ठीक है? Is this okay? Clear? So we understand. Now last line. All these formations above were already formed. All these formations above were already formed by when? Were already formed 4 billion years before present. Already formed 4 billion years before present. Is this okay? पक्का? Last bench आपको भी क्लियर है ना? You are my special students, है ना? Most intelligent one, मैंने कल बोला भी था. तो क्लियर है? Good. Let's go beyond. Should we? अभी ब्रेक का टाइम तो हुआ नहीं है. We have time now. The next thing that we have to do is we have to understand the life, how life evolved, and how the atmosphere changed, and how did we come to the present. So ये भी कर लें अभी जल्दी से, ठीक है? Okay. So should I start the story of life? Okay. So in your terms, what do you understand? What is the most basic things in terms of science that are required for life? सबसे पहला ऑक्सीजन. ओके, ऑक्सीजन इज रिक्वायर्ड फॉर सस्टेनिंग लाइफ, नॉट मेकिंग लाइफ. वो सस्टेन करने के लिए चाहिए ना, जब आप ब्रीथ करोगे. बनने के लिए क्या चाहिए? यू नीड वाटर. ओके, लेट अस सी. सो द नेक्स्ट सब हेडिंग इन योर कॉपी इज इवोल्यूशन ऑफ लाइफ एंड फॉर्मेशन ऑफ द थर्ड एटमॉस्फेयर. राइट? डू पुट दैट सब हेडिंग फर्स्ट. द इवोल्यूशन ऑफ लाइफ, evolution of life and formation of present life supporting atmosphere, which we call as third atmosphere, because your NCERT gives you this word, third atmosphere. That's why I'm using. ठीक है? So that's your subheading now. So for life, as you said, okay, we need O2, you need H2O, और क्या चाहिए? The things that you are giving me are not needed for life in its most primary form. Bacteria don't need water, and bacteria, many of them, do not require oxygen. We call them as anaerobic bacteria. Okay, they don't need oxygen to survive. Right? What else? What do they need? For formation. I'm again and again saying formation. Formation of life, what do you need? You need cell. Simple. And for formation of cell, what do you need? You need the DNA, RNA. Yes or no? Amino acids, nucleic acids. They are the basic. Yes or no? And what are the amino acids and nucleic acids etc. made up of? Carbon, hydrogen. Yes or no? Nitrogen in that form of amino acids, amines, proteins. यही सब चाहिए ना? So for life, right? For beginning of life, the elements that you need for life, okay, are elements such as carbon, हाइड्रोजन, नाइट्रोजन, ऑक्सीजन, और क्या चाहिए? इन दोज न्यूक्लिक एसिड्स एंड अमीनो एसिड्स, व्हाट ऑल डू वी हैव? हाँ, सल्फर, और डू वी हैव सल्फर? ओके, और कुछ? देखो यार, आपको मतलब ये बिल्कुल सिंपल. सो आई वांट यू टू राइट दिस इन योर कॉपी दैट फॉर लाइफ, इवोल्यूशन ऑफ लाइफ, वी नीड सेल, a simple cell. Because the way non-living thing, building block is atom, the building block of life is a cell. Life starts with a cell. That's the building block of life. The simplest life is a single cell. You call it as a unicellular organism. है ना? तो सबसे simple life क्या है? Simple cell. A unicellular organism. So that is the building block. You can't have life without its building block. What is the building block of cell? Of life? Cells. And for cell you need amino acids and nucleic acids. ठीक है? DNA का फुल फॉर्म क्या है? देखो, उसी में आ गया. ठीक है ना? And do you get it? So for cells you need amino acids and or amines and nucleic acids, and for them you need carbon, hydrogen, nitrogen, oxygen, sulfur, etc. And these elements were already present on Earth, but they are present on many other planets. So why were the other planets not giving us life? So there's something more. So one is the chemical requirement, the elements which the Earth already had. Okay, and so for life one, we need elements which will form amino and nucleic acids, which will form cells. ठीक है, which will form the cell, and that is the building block of life. Building block of life. One. Second, apart from these chemicals, what else do you need? You need physical condition also, right? You need a physical condition. A set of physical conditions are also required for life to start, right? So the first is elements, second set of physical conditions. What are these set of physical conditions? First, the most important is the temperature. Temperature. What temperature? Where H2O can exist in all three forms. What are the three forms of H2O? Solid, liquid, gas. In what temperature range do you find H2O to be able to exist in all the three? Somewhere around 0 degree to somewhere around 100 degree. So that is the temperature range that you need, right? And liquid mostly remains in that 0 to 100 degree. So you need that temperature. Liquid water is needed. You said water. Water is nothing but liquid H2O. That's what you mean, right? If there is only steam, will life exist? No. If it is only extremely frozen ice, will life exist? Again, no. Only microbes might. You get it? So for life you need liquid H2O, right? So this is the first temperature. You call it as livable temperature. Livable temperature range, which is 0 to 100 degrees Celsius. But 100 is also extreme. So you need somewhere in between. You need something like 10, 15 to 30, 40 kinds. That is a livable range. Is that okay? Because 0 is extreme, so is 100. Okay. One. Apart from this, और कुछ चाहिए? What else do you need in terms of the physical condition? Come again? Sorry? Fresh air. So when you say fresh air, what do? Acha. Sorry. Extremely sorry. So you need pressure. Okay, and pressure comes from atmosphere, and atmosphere is your air, right? And what kind of air you need depends, right? Depends, because for life sustaining organisms you need oxygen. So oxygen rich atmosphere is also needed, but that is not, as I again said, not needed for beginning of life. तो पहले हम beginning of life पे जाते हैं. Pressure भी चाहिए, that's okay. So you need an atmosphere, and you need a temperature, and atmosphere will give you some conducive pressure. ठीक है? What else? और कुछ? Temperature is one of the most fundamental things there. ठीक है? Temperature. And what decides the temperature of, for example, a planet? What decides the temperature of a planet? The distance from its respective star. हमारे sun से नहीं, ठीक है? From its respective star. Okay. So there has to be a conducive distance from its respective star depending on the size of that star and that planet. If that star is big, the distance can be more. If that star is small, the distance can be less. So this conducive distance from the star where the temperature is livable, right? Please listen to me carefully. This conducive distance, for example, if this is the sun, okay, or the star, and with respect to that star, the conducive distance range is, let us say, this, around it. This is the conducive distance from that star where the temperature is livable. Now, if you are closer than this, you are in the hotter zone. If you are farther than this, you are in the colder zone. And in both, life cannot survive. Right? Life can only survive in this conducive distance. So this is conducive distance. We call this as the, क्या नाम है इसका? Goldilocks zone of a star. Right? So only planets which are in the Goldilocks zone of that star are the planets where life can start or survive. Do we get it? So this is the importance of Goldilocks zone. Goldilocks zone is the conducive distance from a star where the planets will have a livable life supporting temperature. Right? Any planet farther than the Goldilocks will be very cold. Any planet closer than the Goldilocks will be very hot. Is this clear? I want you to note this down. This is the second. That's the physical condition. Okay? So please write down. So first condition we wrote elements. The second condition, physical condition, in that where you have written all this temperature, etc. Hopefully you have written this temperature वगैरह ये सब लिख लिया. So under that write down. If you want, you can make this diagram also. ठीक है? That because life can start and survive, life can start and survive. First it has to start, then it has to survive. Okay, start and survive only in a livable temperature range. Only in a livable temperature range. Comma, livable temperature range, neither too hot nor too cold. That's what we mean by livable. Neither too hot nor too cold. And what is that livable? Where all the three forms of water can coexist. Right? So any planet which can support this is livable. Okay, you need all the three because otherwise you won't get clouds. Okay, and what do ice do? What is ice? Nature's mechanism. If I ask you, nature में ice क्यों बनाता है nature? What does ice do for nature? Ice is the storing mechanism of nature above sea level. Wherever nature has to store water above sea level, right, and not make it flow, ice is the mechanism. It freezes it. So it freezes it on top of mountains, it remains there. It freezes on top of continents, it remains there. है ना? And when nature has to make it flow, what is the thermostat? Temperature. It turns on the thermostat, temperature बढ़ा देता है. When the temperature will increase, what will happen? ठीक है? So mountain tops are nature's water tanks. And ice is the stored water. ऐसा आप अपने घर के ऊपर छत पे टंकी में पानी भर भर के रखते हैं, है ना? और जब जरूरत हो तो नल चला देते हैं. नेचर का नल क्या है? टेम्परेचर. उसको जब नल चलाना है तो वो टेम्परेचर बढ़ा देता है, सब बहने लगता है. ठीक है? डू यू गेट इट? राइट? सो लेट अस कम बैक. सो दैट लिवेबल टेम्परेचर, वेयर वी रोट लिवेबल टेम्परेचर, वहां से अब आगे कंटिन्यू. वेयर वाटर कैन एग्जिस्ट इन ऑल द थ्री फॉर्म्स. Where water can exist in all the three forms. Full stop. The temperature of a planet, depends on temperature of a planet depends on the distance from its respective star. Distance from its respective stars. full stop. Hence, for every star planet system, there is a conducive temperature belt around the star. There is a conducive or livable temperature belt around the star, which we call as the Goldilocks zone of the star. Livable temperature belt of the star, which we called as the Goldilocks zone of the star. ठीक है? Yes, belt होगा ना, पूरा range होगा. It will be some kilometers wide. Okay, livable temperature belt around the star, which we call as the Goldilocks zone of the star, as shown. This thing, this diagram, the star and the Goldilocks zone around it. ठीक है? Hence, only planets within the Goldilocks zone. Only the planets within the Goldilocks zone can support life. Only the planets within the Goldilocks zone can support life. Is this okay? Clear? So if we have to look for life in the universe, where should we look? सबसे पहला, a star which has formed after a supernova explosion. Planet चाहिए ना, Goldilocks zone तो बाद में ढूंढेंगे. ठीक है? So सबसे पहला, star which has formed, क्योंकि हर स्टार का Goldilocks zone हो सकता है, बट प्लैनेट भी तो होना चाहिए. किधर रहेंगे? You get it? So first you need a planet star system. You don't need just a star. That won't help. So you need a planet star system, which means the second generation stars. हमने कल बात किया था ना, सेकेंड जनरेशन. शाहरुख खान का बेटा का नाम लिया था मैंने. मेरा कुछ पर्सनल नहीं है उनके अगेंस्ट, ऐसा मत सोचना. ऐसा ही, मतलब रिसेंट न्यूज में था, आप लोग ने सुना होगा. ठीक है, राजकुमार का बेटा का नाम लूंगा तो बोलोगे वो भी मर गया सर. ठीक है, तो इज दैट ओके? So second generation star, and for those seconds, so first we'll figure out where all second generation stars will form. Then around those second generation stars we'll look for the Goldilocks zone. Then in that Goldilocks zone we should look for planets, and then figure out whether life exists on that planet or not. So see how our understanding of all this narrows down or makes us more focused in figuring out life in the universe. हम लाइफ ऐसे ही नहीं ढूंढते रहेंगे. ठीक है, बिकॉज ऐसा मिलेगा नहीं कुछ. इज दिस ओके? क्लियर? सो लेट अस गो बियॉन्ड दिस. शुड वी गो? तो टेम्परेचर समझ में आ गया, एंड दिस वाटर रिक्वायरमेंट डू यू अंडरस्टैंड? राइट? सो दिस इज द सेकंड रिक्वायरमेंट. ओके, नाउ हाउ डज लाइफ स्टार्ट? For life to start, you need a cell. And what is a cell? A cell is nothing but a very complex molecule. Simple. वो केमिस्ट्री का कॉम्प्लेक्स मॉलिक्यूल है और बायोलॉजी का सिंपल सेल है. ठीक है? सो अ सेल इज नथिंग बट अ वेरी कॉम्प्लेक्स मॉलिक्यूल. राइट? मॉलिक्यूल्स वी अंडरस्टैंड. Molecule is nothing but where lot of atoms have come together to form something. ठीक है? So a cell is nothing but a very complex molecule which requires a very high degree of chemical reactions. One, and second, it also requires the whole molecule to hold together. Right? So if you try to understand cell in its, मतलब ऐसा नहीं लाइफ क्या है तो आप फिलोसफी स्टार्ट कर दो. सर लाइफ कैसे बताएं आपको क्या क्या है, ये सब नहीं बोलना है. लाइफ क्या है? सर लाइफ इज सेल, एंड सेल इज नथिंग बट अ वेरी कॉम्प्लेक्स मॉलिक्यूल. राइट? एंड हेंस इट इज मेड अप ऑफ lot of compounds, right? Molecules within it. Every cell is made up of lot of other molecules within it. Right? There are millions of atoms within a cell. Okay, and what holds all of that together? What can hold? One is that boundary of the cell, है ना, जिसको cell wall और क्या क्या बोलते हैं हम. I won't get into that. I don't need to. वो biology में नहीं घुसना है हमको. The purpose is not biology. The purpose is something else. So just try to understand. So you need lot of atoms to hold together, and for that you need a medium where lot of reactions can take place and they can still go on combining together. So you need lot of reactions to take place and you need all those molecules to continuously interact and hold together and bind. Now for that, what kind of medium do you think is conducive? Can you have in the air those millions of atoms forming one molecule? Is air a conducive medium? No, because in the air you never find any floating cell. Air is a very dynamic medium. It moves very fast. Right? So air is a too dynamic medium and hence very complex molecules do not form in air. वो मिलते ही नहीं है. You test any air, any place, any planet, you will never find very complicated molecules. The most complicated molecules you might find is something like oxygen, nitrogen, ammonia, methane, that's it. One single molecule. उससे complicated molecules don't form in air naturally. Do we get it? आ रहे ना? Some of the more complicated might be things like CFC etc. वो भी उतने complicated नहीं होते. They are not made up of millions of atoms. But a cell is made up of millions of atoms. So it requires lot many reactions. So is air a conducive medium? No. Why? Because air cannot support such complex molecule formation because air is too dynamic. ठीक है? Now let us come to solid. Can such reactions take place within solids? Again no, because so many chemicals can't move freely in a solid state. So solid state is also ruled out, which means atmosphere is ruled out and land is also ruled out. So neither in gaseous nor on solid land you can have, within solid land you can have such reactions. Okay, so what medium is conducive? A medium which is dynamic enough as well as not too dynamic. Why dynamic enough? So that those reactions will take place, and not why not too dynamic? So that the molecules can hold together. If the molecules don't hold together, life cell तक पहुंचेगा ही नहीं. आ रहा है समझ में? So the first thing you need to understand here is that cell, the beginning of life itself, is a very complicated million of atom formation. Okay, and for that simplest cell also to form, you need a medium which can support so many reactions to take place, interact and hold together. Right? What will allow all the reactions to take place? A fluid medium. What will allow it to hold? Not so fluid medium. Okay, so दो fluids हैं हमारे पास, liquid and air, gas. So gas is too fluid, liquid is okay. It has its own viscosity, it has its own surface tensions, so it will hold. That's why in water bodies, naturally also complex molecules form. Are you understanding me? Why? Because the reactions can also take place and they can also hold together. Is this okay? So now you have all the required chemicals, you have all the required temperature conditions, and you also have a medium. अब चाहिए क्या? What more do you need for life to start? You need the energy for those reactions to take place. That's it. Energy for the reactions to take place. ठीक है? And so, if I ask you, was the global ocean a conducive place for life to begin? We can. That's why when we look at the other planets, we look for water. Right? We don't look for H2O there. H2O बहुत जगह है. Water नहीं है. ठीक है? Because when we are looking for life, we are also looking for water. ठीक है? So, the global ocean was a good place for life to start, but then you needed energy in the global oceans. Right? Energy in the global ocean, so that the reactions can take place, because for very complicated molecules, you need lot of energy for the reactions to take place. है ना? हम ऐसे ही करते हैं ना? How do we do reactions? We either heat it up or you pass electric current, right? And then those chemicals react and they turn into a molecule and they give you something, right? Now, did we have heat and electric current at that time? Let us see कौन सोच पाता है. Volcanoes was the heat source, because volcanoes were taking place inside the ocean. So we had ocean heat, heat in the ocean, but where in the ocean? At the bottom of the ocean. We did had heat sources, and they were extreme heat sources, right? And continuous heat sources for those reactions to possibly take place and those molecules to possibly form. Do we get? I'm just talking of the possibility here. Keep this in mind. Okay? And did we had electric current also? Where from? Clouds. The lightning from the cloud. Because we already had clouds, and we already had rains, and it was for millions of years and continuous. So we can have lightning, and lightning can fall in the water. And once it falls into the water, near the surface of the water, if the other chemicals were present, it can lead to those reactions. Are you समझ में? Because you need only these two things in terms of energy, either heat source or light, electricity. Because both of them help in chemical reactions to take place. This is something that we do also. Even in our laboratories, we make molecules like this. Is this okay? ठीक है? And these two conditions were simultaneously present on the earth over a huge area, the ocean floor as well as the ocean surface. And that's where it is said that because of all these conducive conditions being present, most probably somewhere, either on the surface of the ocean or at the bottom of the ocean, life started. The first molecules were formed, right? The first molecules which ultimately gave us, so amines, amino acids, something like this were formed, and then they reacted and ultimately they gave us the first cell. So this is how the first unicellular organism came into being. Where? In the ocean. So life started in the ocean. इतना ही हमको बायोलॉजी समझना है. इसका आगे का बायोलॉजी you do in your biology class. Geography के लिए मुझे इतना ही चाहिए. Is this much understood? Can I assume? So if I ask you what are the conditions for life to begin in terms of your biology wala thing, you need the elements which can form you those basic molecules. Second, you need the physical conditions such as the Goldilocks zone conditions, and third, you need energy source which was present over and below the ocean in the form of lightning and volcanic activity. So the oceans became the laboratory where those molecules were forming and forming and forming for millions of years, and over all those 400, 500, 300, 200 millions of years, when the reactions continued, at some point somewhere around 3.8 billion years before present, as per your NCERT, the first unicellular organisms were formed. Clear? So do we understand this life cycle? Yes? Should we write? लिख लें? Right. Ma'am, any doubt online? None. So, let us write down. अच्छा, break चाहिए? इतना फोकस पक्का नहीं चाहिए? किसको चाहिए ब्रेक? आपका हाथ खड़ा हुआ था? You had some question here? That's okay. You need a break? Anyone who needs a break can walk out. देखो, जब भी आपको बिल्कुल मतलब वो strong वाला nature's call आ जाए, ठीक है, तो पूछना पाछना नहीं है, चुपचाप से चले जाना है, ठीक है? और अगर ब्रेक चाहिए तो बोलो एक बार, मतलब पक्का? इमोशनल तो नहीं हो ना? सर आपने कल ही बोला था, आज ही मांगेंगे तो बेशरम कहलाएंगे. दैट्स ओके. इतना बेशरम हम अफोर्ड कर सकते हैं. हाँ, वेरी गुड. देखो थोड़ा बेशर्मी मैंने बोला चलता है ना, बोल सकते हैं. ओके, 5 मिनट. सो टेक अ 5 मिनट ब्रेक. द वंस हु डोंट वांट टू मूव अपना कॉपी वॉपी रिवाइज करो. द वंस हु वांट टू मूव जल्दी से आ जाओ. 5 मिनट्स. यू हैव अ डाउट? बोलो बोलो. आपका भी डाउट है? हाथ उठा रहे थे आप? नथिंग. हाँ जी बोलो. what broke down? Ocean floor broke down. Yes. Then it melts and segregates and forms a volcanic eruption. Can we take a rock? Not ocean, volcano. वो कहाँ पे सिंक हुआ है? मैग्मा में, हॉट मैग्मा. ओशियन में सिंक नहीं हुआ है ना. हाउ विल ओशन फ्लोर सिंक इन द? ठीक है, मुझे डाउट हो गया, आपको समझ में भी आया पूरा कॉन्सेप्ट, क्योंकि आपने तो ओशन में डुबा दिया कौन। अभी ठीक है, आगे बढ़े। अभी हो गया 5 मिनट, हो गया 2 मिनट और चाहिए, 2 मिनट और चाहिए, दे दो सर, क्या जाता है 2-4 मिनट का लाइफ में क्या मतलब है। आर यू फीलिंग ओके नाउ? ओके, सेटल डाउन प्लीज फास्ट सभी लोग। ऑलराइट, सो शुड वी स्टार्ट द डिक्टेशन? लिखना ही था हमें बिफोर द क्लास, नो मेजर डाउट्स होपफुली। डाउट? हाँ जी बोलो। हाँ, विदाउट एटमॉस्फेयर लाइफ कैसे एग्जिस्ट कर सकती है? नॉट द मोस्ट बेसिक एंड एनारोबिक लाइफ। एनारोबिक वर्ड होता है एक, anaerobic means something that can survive without air, right? And when you talk of the microorganisms, right, not the bigger organisms, but so all the bigger organisms require air, right? But some microorganisms can grow and have been found in regions where there is no oxygen or atmosphere. For example, when you go close to the deepest of the trenches, okay, or near volcanic activity in the ocean floor, there you do find some microbes which are anaerobic. Okay, they live by what you call as chemosynthesis. ठीक है, जैसा फोटोसिंथेसिस एक प्रोसेस है, वैसा ही एक केमोसिंथेसिस भी प्रोसेस है। ठीक है, तो उनको लाइट, एयर, वो सब नहीं चाहिए, राइट, बट दे आर वेरी सिंपल लाइफ फॉर्म्स। ठीक है, कीमो या केमो, हाँ, केमोसिंथेसिस के। Okay, now I think your question is, sir, did the initial life and the initial bacterias live without air? Is that your question? When you talk of the bacteria, you have something called as archaeobacteria, right? And eobacteria. They don't need air, right? And they were archaeo का मतलब ही होती है, archaeo, that word comes from archaic in English, which means the oldest. So the oldest bacteria that we have, the archaeobacteria, they were amongst the first to evolve, and they were something that do not require, not even photosynthesis started much later. Your NCERT gives you the photosynthesis started somewhere around 3 to 2.5 billion years before present. It's a very late process, photosynthesis. ठीक है, before that the living organisms did not require photosynthesis and they could still survive. ठीक है, I'm giving you from your NCERT. Photosynthesizing bacteria is late process है, ठीक है. Okay, should we go beyond? So now let us write down, should we broadly clear it out? ठीक है, कि life without atmosphere भी हो सकता है. NCERT में लिखा है कि life started around 3.8 billion years before present and photosynthesis started around 3 to 2.5 billion years before present. थोड़ा ध्यान से पढ़ना है, मैंने भी वही बुक पढ़ा है, थोड़ा ध्यान से एक बार और खोल के देख लो, कुछ और मिले तो बताना, अगर रिवाइज कर दिया एनसीईआरटी ने तो. ओके, आगे बढ़े, गुड, लिख लो. सो we were talking of this life thing. Okay, so under this you are writing that for life to evolve, life to start and evolve, write this way, for life to start and evolve, we need some simple life supporting conditions. We need some simple life supporting conditions to be fulfilled. life supporting conditions to be fulfilled, such as basic elements, some basic elements required to form amino acids and nucleic acids. Amino acids and nucleic acids which help in formation of the building block of life, that is the cell. The building block of life, which is the cell. Okay, that single cell. Okay, cell or single cell. Full stop. Hence we need basic elements such as carbon, hydrogen, oxygen and nitrogen. Carbon, hydrogen, oxygen and nitrogen for forming amino acids. And also phosphorus for forming nucleic acids. Also phosphorus for forming nucleic acids. Full stop. Amino acids and nucleic acids are themselves complex molecules. Amino acids and nucleic acids are themselves complex molecules, which form more complex molecules the more complex molecules called as the cell. Okay, full stop. Now, for life, we also need physical condition of the Goldilocks zone. For life, we also need the physical conditions of the Goldilocks zone, where H2O can exist in the three forms. H2O can exist in the three forms. Full stop. Also for starting and continuing such complex molecule forming reactions, also for I think starting, right? Starting, I said, also for starting such whatever and continuing such complex molecule formation. We need energy source. Which were present in the oceans, as the volcanic heat below the ocean, and the lighting energy, the lightning that falls from the clouds, right? Lightning energy above the ocean floor, not the light energy. This is lightning. I hope everyone understands, right? Lightning and thunder, wo wala. Lightning energy above the ocean floor due to the continuous rains. due to the continuous rains. Lightning energy above the ocean floor due to the continuous rains. Full stop. The oceans were also the conducive. The oceans were also the conducive. Oceans were also the conducive liquid medium. Liquid medium for such complex molecules to form. Also the conducive liquid medium for such complex molecules to form. Full stop. Hence, as all these conditions were favorable on Earth, the oceans became the global laboratory. The oceans became the global laboratory and around 3.8 billion years before present, around 3.8 billion years before present, the first single cell organisms were born, or were, you can write, were born on the earth, born or formed on the earth. Right? What were these organisms? We call them as archaeobacteria. Right? Archaeobacteria were amongst the first bacteria to be forming on the earth. Archaeo itself means the oldest. Okay? Archaeological, archaic, that's where it means. Okay. So one of the first bacteria to form this way were the archaeobacteria. You can write that name also. One of the first bacteria to form this way were the archaeo, A-R-C-H. One of the first bacteria to form this way were the archaeobacteria, A-R-C-H-A-E-O, archaeo, A-E-O, archaeobacteria, and eubacteria, EU, we also call EU bacteria. The whole name is eubacteria, one word. Eubacteria, that is one word. Archaeobacteria and eubacteria, full stop. They were the non-photosynthesizing bacteria. They were the non-photosynthesizing bacteria. Anaerobic, non-photosynthesizing. Full stop. Gradually, non-photosynthesizing anaerobic bacteria. Gradually, anaerobic, A-N-A-E-O-R-O-B-I-C, aerobic. Aerobic means doesn't need air. Aerobic means air. Anaerobic does not need air. Okay, anaerobic, non-photosynthesizing bacteria, which could survive in the intoxicating atmosphere. Which could survive in the intoxicating air mixed oceans. Intoxicating air mixed oceans. Because in the ocean, the intoxicating air was mixed, right? Which could survive in the intoxicating air mixed oceans. Okay, full stop. Gradually, with further evolution, photosynthesizing organisms were formed. Photosynthesizing organisms were formed. The first being cyanobacteria, C-Y-N-A-O, CYAN, cyanobacteria we call it. CYANO, cyanobacteria. CYANO bacteria. Cyanobacteria, they were photosynthesizing bacteria around 3 to 2.5 billion years before present. Around CYANO, cyanobacteria, around 3 to 2.5 billion years before present. What was special about these bacteria? They were photosynthesizing bacteria. Photosynthesizing means they would use the sunlight and release oxygen. Right? Use sunlight, take the CO2 and release. Hence, gradually where was the CO2 now started going? When photosynthesis starts, the atmosphere that we had initially, it was rich in ammonia, methane, CO2, etc. And the rains were mixing all that atmosphere and bringing to the ocean, right? So gradually the ammonia and methane was going into the ocean. That CNH went into doing those reactions because ammonia is NH3 and methane is CH4, and for those nucleic acids and amino acids you need CNNH. So ammonia and methane was being consumed in forming those life forms, right? CO2 was not getting consumed to a great extent. Now what started consuming the CO2 also in the ocean? Photosynthesis. Okay, so when photosynthesis started, just give me a moment. When photosynthesis started, now can you see the cycle how the ammonia, methane and CO2 was now getting gradually consumed in the ocean? The ammonia containing nitrogen and hydrogen and methane containing carbon and hydrogen was being consumed by these bacteria in those reactions, right? Life forming reactions. Now only CO2 was left. CO2 was also dissolved by the rain and brought into the ocean. That's how atmospheric gases go into the ocean. The rains over the ocean dissolve the gases and take them into the ocean. But now CO2 was concentrating in the ocean. So what started? The photosynthesizing bacteria. When the photosynthesizing bacteria started, they started breaking down the carbon dioxide, right, and producing sugars. That's what photosynthesis does. It produces C6H12O6, okay, and releases oxygen. So it also started breaking the carbon dioxide, consuming the carbon and releasing oxygen. So gradually the ocean will start becoming rich in oxygen and poor in carbon dioxide. When the ocean will gradually saturate in oxygen, then where will the oxygen start getting released into? Atmosphere. So rain is bringing down the CO2 and photosynthesis is releasing back oxygen. Do we get it? So in this process, the nature of the atmosphere is also changing. Can you see? Right? Ammonia is getting reduced and gradually the non-reacting nitrogen molecule will start getting released. Nitrogen molecule is a non-reacting gas. That's why it is so much present in the atmosphere. It doesn't react fast. Okay? So when that ammonia is broken, some nitrogen is released back into the atmosphere, okay, as N2. And oxygen was getting released back from photosynthesizing cyanobacteria. Is this okay? So this is how the nature of the atmosphere was also getting changed and the nature of life was also getting changed from non-photosynthesizing to photosynthesizing. Okay, cyanobacteria is said to be the precursor of what you call as chloroplast in plants, right? The element which does photosynthesis in plants, right? And in your body, what consumes oxygen? There is something called in your cell as mitochondria. Mitochondria presently is part of our cells, but when it evolved as a separate bacteria, right? That's why when you read the biology of mitochondria, you realize that it has a very different structure from the rest of the cell. ठीक है? So mitochondria also, mitochondria, the part which uses oxygen, right? Cyanobacteria produced oxygen, which gradually turn into the plants into chloroplasts, and mitochondria, which uses the oxygen in every cell, also evolved as a bacteria. It evolved as a oxygen consuming bacteria. When cyanobacteria evolved, simultaneously mitochondria also evolved. ठीक है? In the oceans. And what were the mitochondria doing? They were consuming oxygen. Right? So now in the ocean, you have both the kinds of bacteria. Oxygen using and oxygen producing. Before this, till you had the archaeobacteria and the eobacteria, they were neither consuming nor producing. Right? So for the initial, you can say almost 1 billion years, oxygen was neither required, neither ways. Only when these two type of bacteria evolved in life cycle, the mitochondria and the cyanobacteria, they gradually created the characteristic of oxygen use and oxygen produce and oxygen consume. Right? Mitochondria is found in every cell, oxygen consuming cell. Chloroplast is not found in every. It is only found in fauna. Fauna or flora? Flora, plants. Flora jisko bolte hain. And fauna means all the other animals. So mitochondria are found in both flora and fauna, whereas chloroplasts are found only in flora. Okay, so flora, the plants produce oxygen, and everything else, including the plants, consumes oxygen. Right? So what is the two power sources here? One side mitochondria, the other side cyanobacteria. Do we get it? This is how this evolution cycle went on. ठीक है, आगे बढ़ें. So do we understand this much? So when did the cyanobacteria evolve? You have written 3 to 2.5 billion years before present, the photosynthesizing organisms started. Is this okay? Now I want you to write simultaneously the oxygen consuming ones. वो भी लिख लेते हैं. Right? Even the mitochondria, which is the oxygen consuming part of the cell. Even the mitochondria, which is the oxygen consuming part of the cell, evolved in this time frame only. Evolved around this time only. Full stop. Because of this, the oxygen in the ocean started enriching, right? Oxygen in the ocean started enriching and gradually saturated the oceans, and started getting released into the atmosphere, started saturating the oceans and started getting released, gradually saturated the oceans, oxygen gradually saturated the oceans and started getting released into the atmosphere, hence changing the chemical composition of the second atmosphere. Hence now NH3, CH4 and CO2 was dissolved by rains, NH3 ammonia, CH4 methane and CO2 carbon dioxide was dissolved by rains and taken to the oceans, or mixed into the oceans, where they were consumed and absorbed, consumed and absorbed, full stop, and simultaneously, consumed and absorbed, and simultaneously the photosynthesizing organisms in the ocean, simultaneously the photosynthesizing organisms in the ocean were photosynthesizing organisms in the ocean were releasing pure O2, which after saturating the oceans was leaking into the atmosphere, right? Which after saturating the oceans was leaking into the atmosphere. ठीक है? Hence, right. So continue to write. Now, is the third atmosphere still completely made? No, there is something more to the story. Okay. So now, what all do you have in the ocean around 2.5 million years before present? Sorry, billion. You have the all the different types of organisms, right? And because you have the oxygen using organisms, actually the beginning of multicellular organisms started from oxygen using organisms. Okay, that's why all multicellular organisms use oxygen, and that's why your question that can life evolve in non-atmosphere condition? Multicellular life cannot exist in non-atmospheric condition. Is this clear? So once you have the photosynthesizing organism, why? Because actually the photosynthesizing organisms, the oxygen part is required in your cells for making the reactions fast. Okay, that consumption, energy production and consumption, because when you need to break those sugars which are made by photosynthesis, you need oxygen. ठीक है, तो वहां चाहिए आपको oxygen in the cell again. Is that okay? Till you don't have the photosynthesizing sugar products, right, the products which are the outcome of photosynthesis, till then you don't need oxygen in your cell. Cell में oxygen चाहिए क्यों होता है? For breaking sugar, releasing energy and water. इसीलिए तो चाहिए होता है ना, सिंपल. सेल्स में यही रिएक्शन होता है. ठीक है. सो फॉरगेट द रिएक्शंस, अभी आपको नहीं चाहिए. ठीक है, मुझे भी पहले नहीं पता था. पहले मैं बायोलॉजी में बिल्कुल पैथेटिक होता था. ज्योग्राफी के साथ मैंने बायोलॉजी के लिए भी हाथ जोड़ा था. बट ग्रेजुअली थैंक्स टू ज्योग्राफी माई इंटरेस्ट इन बायोलॉजी ग्रू एंड नाउ आई रीड लॉट ऑफ बायोलॉजी ऑल्सो. ठीक है. सो दैट्स आउट बिकॉज यू हैव दोस क्वेश्चंस. ठीक है, लाइफ स्टार्ट कैसे हुआ? सो द सेल केम. I didn't understand the cell, so I had to figure out about cell. Then I have to figure out bacteria. Then I have to figure out, and that's gradually how your interest in different things grows. ठीक है, तो good. So I hope ऐसा ही आपके साथ भी होना चाहिए. Right? Don't leave those questions when they come to you. पहले छोड़ सकते थे. पहले आपको कुछ बनना था और UPSC के एग्जाम में वो सब पूछते हैं. So you have to gradually develop the interest for the subjects which you disliked earlier. ठीक है, then things will start falling in line for you, right? Then you will have less unanswered questions with you. Okay, so should we proceed? यहाँ तक समझ में आ गया? Now you can write the process of photosynthesis. The process of photosynthesis started giving us multicellular organisms, complexer multicellular organisms known as marine fauna and flora. Marine fauna, marine animals and marine flora. ठीक है, marine fauna and flora. What is the simplest marine fauna? हाँ, वो कौन सा ग्रुप है? You have something called as phytoplanktons. You must have heard, right? And zooplanktons, plankton group. ठीक है. So phytoplanktons are some of the simplest photosynthesizing organisms in the ocean. This is how the complexer photosynthesizing organisms gradually evolved. Is that okay? Obviously the life trees will be long, you will have many more organisms, but phytoplanktons, right? So abhi hame why? Because this word phytoplanktons will keep coming in your ocean part, right? What are phytoplanktons? Phytoplankton, P-H-Y-T-O, phyto, that word comes from phyta, which means plant-like, and zoo, animal-like. Okay? So we have two types of planktons in the ocean, which are the simple organisms, simple multicellular organisms. Okay? The phytoplanktons which produce oxygen in the ocean. In the ocean you don't have plants producing most of the oxygen. In the ocean most of the oxygen is produced by phytoplanktons because they live close to the surface of the water. They keep absorbing the light and they keep producing oxygen. Okay? So this is how gradually the more complexer multicellular organisms evolved, right? And we had different plants and different animals in the oceans. Is this clear? Okay. So now you have the multicellular animals and plants in the ocean, and approximately 550 million years before present, life started coming to the edge of continents. Okay, on the edge of continents. So gradually those multicellular organisms kept growing, and different types of multicellular organisms you had, right? Initially the gel-like, the jelly-like, like the jellyfish, right? Or the coral reefs, which are also jelly-like. So initially we had those kind of animals. Then we had the backbone animals, the vertebrates. Okay, gradually. So that's where the fishes grew, right? And then you further had the amphibians. What are amphibians? Amphibian animals, the ones who can co-live or survive both on land and ocean. So they were the first animals to come on the land from the ocean. Right? Which were the first animals to come on the land? Amphibians. Do we get it? So the amphibians were the first animals who came on the land and started living on the land. Is this okay? And then gradually from the amphibians we had the reptiles growing. Reptiles. Okay? Right? And then from the reptiles you had the birds and the dragons, all those, what you call as dinosaur family wala. Wo sab. Is that okay? And we also had the mammals growing. This is how the animal life cycle went on. Right? So first you had the amphibians, then you had reptiles, then from the reptiles who had the backbones but could not stand erect. Okay? Then gradually you had the dinosaurs and the birds. Right? And you also simultaneously had the mammals. Now all the things before mammals were laying eggs, including the fishes. All of them, amphibians, birds, all of them lay eggs. Which were the first ones not to lay egg? Mammals. Okay? Mammals are the first ones to not lay eggs. This is how the life cycle went. So then you had mammals, and then in mammals you had apes, right? And then gradually we came up to human being. That's how the cycle goes. Is this okay? So when did life on land started? 550 million years before present. With which life form? Amphibians. Before that you had fully marine, and mammals and all are mostly fully terrestrial. Mostly. Right? Usme bhi kuch hai in between. We won't talk of all that. Okay? I don't want to right now. But I hope you understand this transition. Aa raha hai samajh mein? So amphibians, reptiles, dinosaurs, birds, mammals. This is the sequence. So when did all this reptiles and birds and mammals and dinosaurs happen? Approximately 500-600 million years before present. Before that, on none of the continents any life existed. The continents were still lifeless. From 4 billion to nearly 600 million, continents were lifeless. No life was there on continents. All the life was only in the ocean. And when the animals came, also the plants came. The coastal plants. The coastal plant variety that you still find on the coast. Okay? Such as the mangroves. Intertidal vegetations. All those vegetation also gradually grew. And then plants started also coming on the continent. When the plants came directly on the continent, what else changed? Now, the photosynthesizing organisms did not need the CO2 to mix in the ocean. Now they could directly take the CO2 from atmosphere and release it back into the, so the whole cycle became shorter and more efficient. Right? So over the last 600 million years, this oxygen production cycle has become more efficient thanks to plants coming to the land. And when the oxygen in the atmosphere increased, that's why the animals also started coming to the land, because now their lungs could get more oxygen and they could grow faster. So their evolution also became faster. Okay? Because multicellular organisms, gradually the more complexer ones have lungs, and your lungs require oxygen. So because the atmosphere could support more oxygen thanks to the plants coming to the land 600 million years before present, hence the animals also gradually came. Do we get it? Broadly, okay? I'm not going much deeper into the body parts and all that, not needed. But broadly do we understand? Okay, so what is the simple cycle? अभी तक हमने क्या लिखा है? Oxygen producing organisms in the ocean and multicellular organisms in the ocean, such as flora and fauna. Flora and fauna is the last word you have written. Just cross check. So you have multicellular flora and multicellular fauna. Fauna means animal, flora means plants. Okay, and these are marine plants and animals, which we have written, I believe. ठीक है, अब इसके आगे का part I will dictate. Any major doubt apart from you? हाँ बोलिए. That is atmosphere का part. ठीक है, ozone forms not from life. Understand it this way. Ozone forms not from life. Ozone molecule formation cycle है एक, जो हम ecology environment में करेंगे. ठीक है, O2 से ओजोन बनता है, UV रेडिएशन से ही. UV A B C 3 टाइप का रेडिएशन है. ठीक है, सो जो हम कंज्यूम करते हैं वहां पे वो रिएक्शन करके ओजोन साइकिल प्रोड्यूस करता है. ओजोन लेयर पहले का बना होगा. अच्छा, ओजोन लेयर का एग्जैक्ट फॉर्मेशन ईयर इफ यू आस्क मी आई वोंट नो, बट ओजोन मस्ट हैव फॉर्म्ड अर्लियर. दे नीड यस. उसी से नहीं, यूवी रेडिएशन पहले भी आता तो ओशन में भी लाइफ डिस्ट्रॉय कर सकता था. ठीक है, तो ओजोन मस्ट हैव फॉर्म्ड अर्लियर. इफ यू आस्क मी एग्जैक्टली द टाइम फ्रेम आई वोंट रिकॉल राइट नाउ, आई हैव टू क्रॉस चेक. ठीक है, व्हेन डिड ओजोन स्टार्टेड फॉर्मिंग. ठीक, सो यू कैन ऑल्सो क्रॉस चेक, आई कैन ऑल्सो, एंड आई कैन टेल यू इन द नेक्स्ट क्लास. ठीक है, आई डोंट रिमेंबर राइट नाउ. मैं आपसे उल्टा पुल्टा नंबर नहीं बोलूंगा. चलेगा? फिगर आउट कर लोगे? फैक्ट है. वेरी गुड. एनीथिंग एल्स? कॉन्सेप्चुअली क्लास में समझ में आता रहना चाहिए. फैक्ट्स मुझसे भी मिस हो सकते हैं. राइट, सो दैट ईदर यू चेक योरसेल्फ और यू आस्क मी, आई विल क्रॉस चेक एंड देन गिव यू. ऐसे ही कुछ भी उल्टा पुल्टा फैक्ट दूंगा, दैट्स नॉट राइट. एनी अदर मेजर डाउट? नन? शुड वी राइट? लिख लें? लेट्स. सो write down this line in the last paragraph itself. Hence this way the marine biodiversity of unicellular and multicellular organisms, unicellular and multicellular plants and animals started thriving in the oceans. Started thriving or growing. Started thriving in the oceans or growing in the oceans. And also started modifying the atmosphere. Second atmosphere will be a better word to write. Also modifying the second atmosphere. Full stop. Next subheading: evolution of life on earth, on land. Next subheading: evolution of life on land. Evolution of life on land. So write down. Around 600 to 550 million years before present, 600 to 550 million years before present, the marine flora and fauna started surviving on the margins of ocean and continent, within bracket the coast or the beach. Coast is a better word, beach is a specific type, so we don't write beach here. On the margin of the continent and the ocean, within bracket the coast, right, which we call as the coastal flora and fauna. ठीक है, which we call as coastal flora and fauna. ठीक है, coastal flora and fauna, such as intertidal plants, and amphibian amphibian animals. Okay. This way, now the photosynthesizing organisms, now the photosynthesizing flora was directly consuming CO2 from the atmosphere, and releasing O2 back into the atmosphere. Therefore, releasing O2 back into the atmosphere, therefore efficiently short circuiting the CO2 to O2 cycle. ठीक है. Hence, more oxygen and lesser CO2 was present into the atmosphere, and this cycle still continues. And because of this richer O2 atmosphere, even terrestrial plants and animals, richer O2 atmosphere, even terrestrial plants and animals further evolved into reptiles, dinosaurs, birds and mammals, and also insects. Okay, the multi-legged organisms. Many of them have evolved from the oceanic marine crustaceans. Okay, that's why you find in the oceans multi-legged organisms, the crustaceans, and many of the insects which came on the coast and gradually evolved, and so this is how that evolution cycle, not exactly so simple, but I'm just simplifying so as to make you understand. ठीक है. So this is how it evolved, and then we had the mammals, and till now the cycle is continuing. ठीक है. Hence, hence this way, Earth's biodiversity became richer. Earth's biodiversity became richer, and gradually the second atmosphere evolved into the present third atmosphere. Right, which is a life supporting atmosphere. Multicellular life supporting, we should say, which is a multicellular life supporting atmosphere. Okay, so this lung development is the major part here. Right, when you talk of the life on land, lungs are the major part because they are the pump of oxygen. Oxygen is taken by your lung, mixed into your blood, taken to the cell. In the cell, the sugars are broken down and energy is released. That's a fast, efficient process of energy release. That's why multicellular organisms are able to do so many things. Is this okay? तो ये सारा हमारा biology है इसका. And when you talk of evolution of life, evolution of man, in mammals, you had different types of mammal evolving at different part. The most developed of the mammals is the placental mammal. Okay. Right? Placental. And in this placental mammal you have primates. Placental means the ones who have placenta, the cord connecting you to your mother. Okay. That is your food line till you are born. Right? And once a mammal is born, the mammalian glands of the mother is the food supply, initial. And then gradually you start picking the food from outside world. Then you had the primates. In the primates you had the apes. In the apes you had the great apes. And then you had the Homo group, the human, the broad human family. And in this you have the Homo habilis, Homo erectus, and finally the Homo sapiens. And in Homo sapiens you have the Homo sapiens sapiens, the modern man. Okay? Because when you talk of Homo sapiens, they are divided into the archaic man, just the Homo sapien, and the Homo sapiens sapiens, the modern man. We are the Homo sapiens sapiens, the modern man. Is this okay? So this is how we go. Okay? Good enough? So that's it. So your human geography will start here. All the rest was your ecology. And now we understand the atmosphere. Now let me ask you a question. Where did all the carbon go? ये carbon कहाँ गया? What do you call carbon chemistry as? Organic means life. Right? It is the chemistry of life. Because carbon has a special character. It is a polymer forming chemical, long chain, and for your molecules you need life supporting complex molecules, you need long chains. Okay? So all that CO2, the C of that gradually goes into the life forms and it is stored in the life forms. So in you and me and plants, the C goes on getting stored. Right? So the global initial carbon dioxide, of that carbon dioxide, the carbon has gone into the life forms. You collectively call all that carbon mass as the biomass. Right? तो उसको हम क्या बोलते हैं? The biomass of this planet. Bio, life. Mass, the life supporting mass. ठीक है? So what is biomass? Biomass is basically all the carbon stored in us. Do we get it? ठीक है? So most of the carbon has gone stored into the different life forms in the oceans, in the plants, on the land, in the ocean, and in the animals. So that's where the carbon is getting stored. That's what your biomass word gives you. Are समझ में? Because that is your organic. We are all, all that molecules that you look into, they are organic molecules. ठीक है? That's why organic chemistry is the biggest chemistry. When you see chemistry, inorganic has a very small set of chemicals to it. Organic chemistry सारी की सारा टाइम ले जाता था स्कूल में भी, याद है? Right? So where is the carbon getting stored? I hope you understand. Where is the oxygen going? I hope you understand. ठीक है? Where is the nitrogen going? Nitrogen goes into your amines and amino acids and your proteins. ठीक है? So that's where chemically it is getting stored in living forms and the rest is in the atmosphere. ठीक है? So this is where we are. Perfect. So have you come to the present earth? Any major doubts? Do we understand the most of the formations in this cycle? Perfect. Great. So should we go beyond this? No major doubts. अच्छा, कितनों को ये समझ में आ गया? जितना भी हमने बात किया, more than 50% is understood. More than 50%. बाकियों का क्या स्टेटस है? नहीं समझ में आ रहा? अच्छा, कितनों को less than 25% समझ में आया? यार ये more than 20, अच्छा बीच में हो फिर बाकी? सर 25 to 50 का बीच में हम ज्यादातर है. How many of you are there? 25 to 50%? सर हम तो क्लास में थे ही नहीं. हम तो इसलिए आ गए, पापा मम्मी ने भेजा हुआ है 12 बजे निकलने. क्या स्टेटस है यार, बताओ. मतलब कुछ तो समझ में आए, इतनी देर से मैं बोल रहा हूं. आर यू पीपल कंफर्टेबल? यस और नो? पक्का? तो बता के मतलब, अच्छा अब बताओ सही सही. हाउ मेनी ऑफ यू आर एबल टू अंडरस्टैंड इन द क्लास? अदरवाइज आई विल चेंज इन द नेक्स्ट क्लास. आई विल चेंज द अप्रोच कंप्लीटली. हाउ मेनी ऑफ यू वांट मी टू चेंज द अप्रोच? सर दिस इज गेटिंग कॉम्प्लेक्स, नहीं समझ में आ रहा है. एकदम सच सच बोलो. हाँ, हाउ मेनी ऑफ यू वांट मी टू चेंज इन द नेक्स्ट क्लास? ये क्या क्लास है? हाँ जी बोलिए. हाँ अच्छा ठीक है. सो सर फ्लो चार्ट थोड़ा इंप्रूव कर लो. ऐसा बोलना है यार, इतना घुमाना फिराना नहीं है. ठीक है. ओके. सी I would try to make it slightly more legible. Okay. And one more thing you can do is, you have that opportunity, you can go back, but I know it will be cumbersome. Go back and whichever part of the flowchart you are not able to do, वो आप फिर से जाकर वीडियो में भी देख सकते हैं. But I would also, comply by your guidelines. What else? और कुछ? मतलब ना बताएंगे, ना सुनेंगे, ना पूछेंगे. सर जो भी कर लो, हम ब्यूरोक्रेट हो चुके हैं. नो कमेंट्स. ब्यूरोक्रेसी का फर्स्ट कैरेक्टरिस्टिक, नो कमेंट्स. कमिटी हैज बीन फॉर्म्ड, रिपोर्ट विल बी प्रेजेंटेड. ठीक है, टिल देन आई कांट कमेंट ऑन एनीथिंग. हाँ जी बोलिए. नहीं, क्वेश्चन मुझे नहीं सुनना है अभी. मुझे अप्रोच के बारे में बताओ. कब क्वेश्चन तो सुनता ही रहता हूँ आपका. मोस्ट ऑफ यू आर पक्का ओके? हाँ, सिंगल वॉइस में बोल सकते हैं. यस सर, नो सर, पक्का? हाँ, ये लगा कुछ अभी. यस, यू ऑल्सो हैव डाउट ऑन? आते हैं अभी. उसका भी डाउट है ना, क्वेश्चन रोका हुआ है मैंने अभी अप्रोच पे बात कर रहे हैं. शुड वी कंटिन्यू लाइक दिस और शुडंट वी? शुड आई डू समथिंग एल्स? आर यू पीपल एबल टू मोस्टली ब्रॉडली अंडरस्टैंड, राइट, डू थिंग्स? मोस्ट ऑफ योर डाउट्स आर ब्रॉडली क्लियर. चल रहा है ना, मतलब चल रहा है ना. ऐसा ये चल रहा है, दो टाइप का होता है. सर बस चल रहा है. सर क्या हो रहा है? ठीक है, पहले अपना डाउट बोलो. बोलो. लिसनिंग, आई विल कम टू यू. या हाँ बोलो. लिसनिंग. यस, we have come from something called as LUCA, our LUCA, there is a word LUCA, which means our universal common ancestor. ठीक है, last universal common ancestor, which is said to have existed somewhere around 3.8 billion years before present. All the living forms that you find on the earth now have evolved from that one last universal common ancestor. That's why most of us, right, are only siblings of, you know, long descendants, long, you know, cycle descendants of one common thing. That's why we are common. So does that answer your question? वो लूका वर्ड मैंने आपको दिया नहीं, आपके बायोलॉजी वाले टीचर दे देंगे. That's why. ठीक है, हाँ जी बोलिए. I said when mammals evolved, what is the difference between all the animals before the mammals? They were all laying eggs, right? So their children were born from eggs. Mammals are the first one in which eggs are not given. But in mammals also, the initial mammals that we had, such as the platypus, that was a egg laying mammal, right? So that was gradually transforming. So first one, right, the platypus as we call it, right? Then after platypus, we had the kangaroo kinds, right? We call them as the marsupials, which carry their children in their bags, right? And then became the pure mammals, which are the placental. So they don't carry their children. Once their children are born, they are separated from the body by the placenta. So the placenta is the last cut, which once released, the child is no more with the parent. And then gradually the child is fed through the mammalian gland, and gradually it starts picking from nature. Right? So that's what your placental are. So in mammals, the most evolved mammals are the placental. That's what it means. Huh? Okay, so once you have these placental mammals, then the mammal tree is also a big tree. ठीक है, in mammals you have different types of mammals ना, cat family सुना होगा आपने, अलग अलग families है. तो उसमें apes एक primate एक family है. What is the characteristic of primate? The first characteristic of primate, as we say, is that it can rotate its arm fully. That's the first differentiator, and it can, there are more things in which gradually other body forms also started modifying, but the first one is that you can rotate your arm, because of which you can survive on trees also, right? And this ape thing, when you talk of this primate and ape group, thanks to them being able to live on the what you call as trees, they evolved faster because they were able to reap the fruits directly, and they were safe from many other animals, right? So they could spend time on more things, and that's how they gradually further evolved. So this evolution cycle of primates have been faster. No other species has shown this fast an evolution, right? That only in a few million years they have evolved from something which was a primate into a human being. So this evolution also is pretty much because of the geography and the biology combined. Okay, rest of it you try to figure out, and when we come to human geography, when I start talking of agriculture, I will take up this story again slightly, starting from primates, because that's where human geography starts. ठीक है, तो प्राइमेट तक जब तक थे हम, एप तक, तब तक नो ज्योग्राफी, दैट इज what you call as zoology and all. After that history starts. ठीक है, so good enough. Now what else? I assume now that I have asked you people, most of you seem to be comfortable, very few of you seem to be understanding. Still most of you are comfortable, which is pretty complex for me to understand. ऐसा कैसे हो गया? सर comfortable है, समझ में कुछ नहीं आ रहा है. ये भी comfort होता है. सर कुछ समझ में नहीं आ रहा है क्लास में, इसीलिए सब कुछ ठीक है. ऐसे हाँ, मतलब कुछ बताएंगे नहीं. एक तो मास्क ने ऐसी जिंदगी बर्बाद कर रखी है. फेस का एक्सप्रेशन टीचर को समझ में नहीं आता है, बाकी एक्सप्रेशन आप ऊपर नीचे करके एडजस्ट कर लेते हो. ठीक है, चलो ठीक है. So now let us talk of this last part that I want to touch before I leave, which is the shape of the earth. There was one more topic. Next class we will come to what we call as the interior of the earth, because formation of the earth we have done. So interior of the earth and magnetism of the earth, which is the source for this, chapter number 3 of NCERT. Right, chapter number 3, interior of the earth. Please do read and come. We will start with that in the next class. Magnetism of the earth, not given in any of your NCRTs or GC Leong. I'll do it in the class, don't worry. Not needed to read. Wherever you will read, it will become more of physics. So I'll try to keep it simple and make you understand. And after that, we start talking of continental drift theory, seafloor spreading, etc., which is obviously not one class, for which you have to read the chapter number 4. When you read interior of the earth, please do not read volcanism and earthquake to start. Right? After the first half of the book, volcanism and earthquakes are given. Please don't read it. Abhi nahi chahiye. So first read interior of the earth. After that, read directly chapter number 4. Once you have completed chapter number 4, then come back to volcanism and earthquake. ठीक है? Okay. So that should be the sequence. Now let us talk of the shape of the earth, should we? And then I'll leave you. Okay. So when we talk of the shape of the earth, basically this is one topic that I generally do before this formation of these layers. But आपका class में थोड़ा sequence change हो गया है. Shape of earth. So when we talk of the shape of the earth, okay, what is the shape of the earth? A light hair. Geoid और बोलो, हाँ, ओवल, स्फेरॉइड, ऑब्लेट, क्या बोला था? ऑब्लेट, स्फेरॉइड और एलिप्टिकल, और बोलो, मैं ऐड कर दूं? आ रहे हैं. आई कैन अंडरस्टैंड, भूख लगना शुरू हो गई है. एज पर पाकिस्तानी रिसर्च, बोल दो. Grenade like. Orange like, और बोलो. ऑरेंज बस, और कोई फ्रूट नहीं? एप्पल नहीं चाहिए? एप्पल लाइक, कुछ अंडा, कुछ नॉन वेजिटेरियंस, एग लाइक, और हाँ सॉरी वाटरमेलन. ठंड में वाटरमेलन याद आ रहा है तुमको यार? मतलब ये थोड़ा सा नया है मेरे लिए भी. ठीक, वाटर. अब इससे ज्यादा मतलब अब इसके बाद बोलना सर वाटरमेलन, उसके बाद स्पोर्ट्स वाले मत स्टार्ट हो जाओ, वो भी लिख देते हैं इधर ही. बॉल लाइक, फुटबॉल, क्रिकेट बॉल, टेबल टेनिस, सब कुछ. और कुछ क्रिएटिविटी दिखाना है किसी का. हाँ, अर्थ में हमें क्या क्या दिखता है? हाँ, अच्छा हुआ कोई बोला नहीं मदर लाइक. ठीक है, वो तो है ही. ओके, गुड. Now, why do we have all these words? And why have I separated this way? Who can tell? Let us see whether you can understand why I have separated this way. बोलो, तेज. Good. These are very good. Geometrical, and the other ones are इसको क्या बोलेंगे? नॉन जनरल. वेरी गुड. सो प्रैक्टिकल, जनरल, और कुछ? Anything else? Now, what is the difference between these two types? What is the difference between the general and the geometrical type? The geometrical type have equations, right? The general types don't have. Orange का equation क्या है बताओ? एप्पल का इक्वेशन, बॉल का इक्वेशन है कोई? राइट. सो जब आपको कोई स्पेस में कुछ प्रोजेक्टाइल भेजना होगा, रॉकेट, तो आप किसका इक्वेशन लगाएंगे? एप्पल ऑरेंज का इक्वेशन से तो काम चलेगा नहीं. देयर यू नीड एन इक्वेशन टू कैलकुलेट थिंग्स. डू यू गेट इट? So that's why when we talk of the shape of the earth, we talk in two terms. The one which a common person can understand, and second, the one which we can apply in our earth related studies where we need equations. So when you need equations, you use geometrical shape. When you need a common man, a child, someone who doesn't want to get into maths of it to understand, you give a general name. Is this okay? That's why we have these two groups. Now when you talk of these geometrical ones, why do we have so much? Actually एक दो आपने नहीं बताए. Sphere like. The simplest geometrical shape that the earth looks like is the sphere. ठीक है, sphere का equation भी simple सा है and it's a simple shape. But that sphere shape equation, if we use in our aerodynamics, right, and astronomical studies, it fails, right, because earth is not exactly a sphere. So even the calculations made assuming the earth to be a sphere prove to be wrong and our projectiles go elsewhere. भेजते कहीं हैं, जाता कहीं है, right? So then you need a more accurate shape, right? So we started looking for which shape in geometry comes closest to the shape of the earth, right? And when we look for the closest shape, the shape is that of oblate spheroid and oblate ellipsoid. So oblate spheroid and oblate ellipsoid are two shapes which are the closest to the real shape of the earth in geometry. Are they exactly same? No. They are the closest. So for our calculation, they give us the best possible equation. Okay, and we use those equations and send our rockets and send our missions wherever we want. Do we understand this? क्योंकि आपको चाहिए उसके लिए, उसके बिना आप कैसा कुछ भी बनाएंगे. ठीक है, clear? Now, still, why do we have two? The oblate ellipsoid is for a non-rotating, therefore no extra rotational bulge, because rotating objects tend to have a extra rotational bulge. When you rotate something, they tend to bulge, right? So when you want the Earth's equation where the rotational bulge is not important, there we use the equation of oblate ellipsoid, whereas when we want to use effect of Earth's rotation, then we use, is it clear to you, dear? And clear है? अभी चलेगा इतना? ठीक है. Okay. So when we have to use a equation which is keeping into account even the rotational bulge of the earth, because earth in reality is rotating. Okay, so what is the shape of the earth without any rotation? Ellipsoid, right? That is the real shape of the earth. And what is the shape of the earth of the practically rotating earth? Right? That is not the real shape. That is the bulged shape. Right? That is the extra bulged shape due to rotation. Is this clear? So we have these two equations. And that's why we have these two names. Is this clear? So do we understand why we have all these terms? इतना सारा terms क्यों है? अब एक term बच गया. Any doubt till now? None? Okay. Now we are left with one more last term. What is that last term? And we have already stretched the time limit, but let me complete this here. What is this geoid? Geoid is the name that we have given to the special shape of the earth. Right? We don't have any geometrical object like geoid. There is no geometrical object except for earth like geoid, and it is not a practical real life shape. Right? It is the special name given to our earth's special shape. So what is geoid? Geoid is the special name given to the special shape of the earth. ठीक है? Earth is special to us. उसको हम बोलते हैं egg like, orange like, अंडा like. ये क्या है? एक ही अर्थ है, उसके shape कोई नाम ही नहीं है कोई. So we created a name for it, and we call it geoid. So geoid is the name given to the special name given to the special shape of the earth. What is the special shape of the earth? The special shape of the earth is the shape of the earth without any tidal effects, the tidal gravitational effects from outside. Because the tidal gravitational effects on the earth change the shape of the earth. Because the water bulges at some place and the water shrinks at some other place. होता है ना? Tides, you understand? Tides attract the water, so the water will bulge in the oceans, and at other places the tides will go down. So the shape of the earth will change because of tides. So in geoid we do not consider the effect of tides. Hence we call it as the equipotential surface. Equal potential. There is no effect of tides by bulging more or bulging less. ठीक है? So what is the shape of the geoid? It is the equipotential surface shape of the earth. Equipotential means no change in shape due to gravity of others. Right? Because potential energy is affected by gravity. I hope you understand. ठीक है? So what is the geoid shape? Geoid is the special shape. वो लाइन आप पहले लिख चुके हो hopefully. Have you written? It is the special name given to the special shape of the earth, and it is the equipotential surface shape of the earth. Which means equipotential surface shape of the earth, which means gravity of others is not considered. Gravity effect of others is not considered. And what is the biggest gravity effect earth gets? Tides. Right? Which means gravity effect of others is not considered. Equipotential means this. Right? Gravity effect of other planets or objects is not considered. Sun, moon, no others gravity effect is considered. So if there is no effect of gravity outside the earth on earth, the shape that the earth will take, we call that shape as geoid, and that will be a equipotential surface. ठीक है? Is this okay? So I hope you understand all these terms. Broadly clear? No major doubts? Yes or no? Pakka? That's it. Thank you. So I think I don't have a class with you this week. I'm leaving. Alright. अभी है, मेरा साथ नहीं होगा. I'm leaving tomorrow, so maybe next week, and maybe online. ठीक है? Maybe online because I might not be here because I'm leaving. My doctor has suggested me to leave. So I'll be leaving from Delhi for probably another week, maybe another week or 10 days or whatever. I believe most of you would be comfortable with the online class also. है ना? नहीं sir. यार आप लोग तो मास्क पहन के आते हो, मुझे एक्सप्रेशन समझ में नहीं आता, मैं दिख ही जाऊंगा, तो थोड़ा चला लो. ठीक है सर. ओके, थैंक यू. ओके, सो दैट्स इट. थैंक यू. अच्छा, I can understand, ma'am. This is the problem of a full offline, because so it becomes, yes, we have to do. I will talk, sir. When I was in class, I don't understand too much. And I was, so there are opposite response also. See this? In the class I didn't understand much, online I understand more. More flowcharts please. Perfectly fine, best in this approach. Perfect flowcharts are very helpful, yes sir.